provide benefit for all. And oh Allah, make these activities a part of our good deed and give your blessing for every speakers and participant and committee of this program. Our Lord, accept the submission from us that you are the all-hearing, the all-knowing. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين السلام عليكم ورحمة الله وبركاته.
Waalaikumsalam warahmatullahi.
Thank you, Mr. Ali Class LCMA. May Allah subhanahu wa ta'ala grant us mercy and blessings throughout this conference. Excellencies, participants, ladies and gentlemen, we are now going to listen to the welcoming speech delivered by the General Chairs of PSTRS 2022. Without further ado, please welcome Mr. Ramon Lapisa, MSc.
Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Honorable Vice Rector of in Academic Affairs of Universitas Negeri Padang, Mr. Dr. Refnaldi. Honorable Head of Research and Community Service UNP, Mr. Yohandri PhD. Honorable our distinguished keynote speaker and invited speaker, Datu Professor Dr. Harith bin Ahmad from University of Malaya, Dr. Taro Sonobe from Kyoto University, Japan, Okta Suryani PhD from Universitas Negeri Padang, Dr. Miss Nisrin Lahmish from Morocco, and Milana PhD, Henry PhD, and Mr. Rizal PhD from Universitas Negeri Padang. Good morning, ladies and gentlemen, fellow speakers, and good morning to all audience joining us online today. On behalf of the committee, it is a pleasure to welcome you all to the PSTRS, organized by Research and Community Service Institute, UNP. This conference offers significant contribution to science and technology. The theme of this particular conference is a special discussion on green technology and applied science for a better future. The scientific manuscript on PSTRS will have the opportunities to be published in Journal of Proceeding. This event held fully online today with keynote speakers consists of Datu Professor Dr. Harith bin Ahmad from University of Malaya, Dr. Taro Sonobe from Kyoto University, Japan, and Mrs. Okta Suryani PhD from Universitas Negeri Padang. We also have 4 invited speakers, Dr. Nisrin Lahmis from Morocco, and Mrs. Milana PhD, Mr. Henry PhD, and Mr. Rizal Satria PhD from Universitas Negeri Padang. I would like to thank you for the support from various party, which is keynote speakers and invited speakers, oral presentation presenters, participants, universities, and leaders who have participated in this conference. And special thanks to also for the committee who have given their help and energy for this event. We hope that with this conference, you could expand your networking and develop the joint research in the future. We look forward to having a successful conference, and we hope that all the attendees enjoy and benefit from this conference. Thank you.
Right. Thank you, Mr. Ramon Lapisa, MSc, for the warm welcoming speech. We surely hope that our participants and presenters could gain fruitful knowledge from the amazing invited and keynote speakers today. Ladies and gentlemen, we are moving to the next welcoming speech by the Head of Research and Community Service Institute. Please welcome Mr. Yohandri, MSc, PhD.
Okay, thank you. Onik, you can hear clear my voice?
Clear and crystal, Pak. Silakan, Pak.
Okay, thank you very much. Good morning, everyone. Assalamualaikum warahmatullahi wabarakatuh. Honorable Vice Rector for Academic Affairs. Our keynote speaker, Professor Dr. Harith Ahmad from University of Malaya. Thank you, Prof. Good morning, and thank you for joining our conference. And also Dr. Taro Sonoe Sensei from Kyoto University. Dua, Dozo Irisku Nagaifmas. Welcome to Universitas Negeri Padang and welcome for PSTRS 2022. And our invited speaker, presenter, participant, and committee. The fourth Progress in Science and Technology Research Symposium has theme this year, Green Technology and Applied Science for the Better Future. In this conference, we invite many participants, researchers, and in education, science, technology, and environmental, as well as engineering. We hope we offer great opportunity for our researchers and expert practitioners to engage meaningful discussion in this conference. And also, we think there are many innovation findings that have been found in science and technology and give benefit for the society. Through this conference, we hope that we could discuss about the global crucial issue and research result and literature study in science and technology and many other topics. And finally, I extend my gratitude and highest appreciation for the keynote speaker, invited speaker, presenter, and participant. My appreciation also goes to the all committee for the organizing this event. And I wish this conference could be useful for the all participants and presenters. And I hope you enjoy this wonderful conference. And thank you.
Right, you are welcome. Thank you, Mr. Yohandri, for the warm welcoming speech. We hope that all participants today could engage in meaningful discussions about global issues and give benefit to the society. Ladies and gentlemen, it is the time for us now to listen to the welcome speech by the Vice Rector of Universitas Negeri Padang for Academic Affairs, Dr. Refnaldi M. Lid. Selamat pagi, Bapak.
Good morning. Can
Good morning.
you hear my voice?
Yes, I can hear it very clearly. And we would like also to request Bapak Wakil Rektor, Vice Rector, Dr. Refnaldi M. Lid to officially open PSTRS 2022. Ladies and gentlemen, please welcome Vice Rector of Universitas Negeri Padang. Silakan, Bapak.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Alhamdulillahirabbil alamin. Shalatu wassalamu ala asrofil anbiya wal mursalin wa ala alihi wa sahbihi rasulillahi ajma'in. Amma ba'du. A very good morning, everybody. The Honorable Vice Rectors of Universitas Negeri Padang, Deans, and the Director of Graduate Schools, Institution Head, Vice Deans, Department Heads, Program Coordinators, invited speakers, distinguished guests, and participants of the Fourth Progress in Science and Technology Research Symposium, which is organized by the Research and Community Service Institute of Universitas Negeri Padang. Alhamdulillah, in this very great occasion, we have the chance to meet again in the virtual room to witness the opening one of the 2022 International Conference Series in Universitas Negeri Padang, which has received very great support from many partners, especially from the University of Malaya and University of Kyoto. We fully understand that it is not that easy to host the online conference due to the post-COVID-19 pandemic situation. Well, ladies and gentlemen, so the themes of this symposium is green technology and applied science for a better future. We are really sorry to say that our rector could not be with us in this virtual room due to the other important event that he has to attend. So, representing directors of Universitas Negeri Padang, I'm very pleased to join the opening of this virtual symposium. I wish to convey my sincere appreciation to the head of Research and Community Service Institute of Universitas Negeri Padang, who has regularly supported the committee for making this conference or symposium event happen today. And this is the fourth symposium. I'd also like to thank all the distinguished speakers for taking time to participate from near and far in today's event. Professor Dr. Harid bin Ahmad from University of Malaya, Dr. Taro Sanabe from Kyoto University, Japan, Dr. Okta Suryani, Milana PhD, Henry PhD, Rizal Satria PhD, and Dr. Ms. Nisrina Lahme from Morocco. I believe that this conference will become a good medium and opportunity for us to learn, communicate, share the newest information about knowledge, concepts, theories, and result of research. And the most important things are to create networking and to collaborate with international experts, as well as institutions in the international levels. Moreover, through this symposium, we can improve the quality of our research as well as innovation and trends for the global challenges. Invited speakers, ladies and gentlemen, please allow me to restate a bit about what experts say about science and technology in today's condition. So the interdependence of science with its resulting discoveries and principles, and engineering with its resulting technologies, includes a number of ideas about how the fields of science and engineering interrelate. One of the ideas that scientific discoveries enable engineers to do their work. For example, the discoveries of the early explorers of the electricity enabled engineers to create a world linked by fast-forward grid and illuminate cities, enable communication, and accomplish thousands of other tasks. Engineering accomplishment also enable the work of scientists. For example, the development of Hubble Space Telescope and very sensitive light sensors have made it possible for astronomers to discover our place in the universe, noticing previously unobserved planets and getting even further insight into the origin of stars and galaxies. So the vision projected by the framework is that the science and engineering continuously interact and move each other forward. New insight from science often catalyze the emergence of new technologies and their application, which are developed using engineering design. In turn, new technologies open opportunities for new scientific investigation. These reflect the key roles of both science and engineering play in driving each other forward in the research and development cycle. Together, advances in science, engineering, and technology can have profound effects on human society in such areas of agriculture, transportation, healthcare, and communication, and also on the natural environment. Each system can change significantly when new technologies are introduced with both desired effect and unexpected outcome. I think some or many of the issues I mentioned previously will be discussed, whether it is in the plenary session and parallel session of this symposium. Distinguished guests, participants, ladies and gentlemen, representing the academic staff, administrative staff, and students of Universitas Negeri Padang, we'd like to thank our speakers and participants for your contributions, which will make this symposium a success. Who could have imagined a better exchange than seeing invited international researchers and speakers from several countries here joining forces in the symposium to share experiences, research findings, and inspiring ideas. And the most important thing is having opportunity to learn many things from the speakers. Ladies and gentlemen, we expect we will learn new ideas from the speakers, which we can adopt and adapt to further improve our work in research. I know that there will be many interesting and useful presentations. I believe many good experiences will be shared and good lessons will be learned. And I'm sure that members of organizing committee have been working very hard. I'd like to thank them for their dedication, time, and effort. I wish also to thank our patrons, individual and organization partners, and volunteers. Without their generosity, we would not be able to create a total environment to support your full participation. Thank you all for your presence and participation, and you are the very important part of the symposium. Please enjoy the symposium. Well, ladies and gentlemen, by saying Bismillahirrahmanirrahim, the Fourth Progress in Science and Technology Research Symposium is officially opened. Thank you. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you, Dr. Rafnaldi Emlit, for the warm welcoming and opening the ceremony of PSTRS 2022. Terima kasih, Bapak. And ladies and gentlemen, we would like to inform you that our 3 keynote speakers has joined us in this virtual meeting room. We have Datuk Professor Harith. Good morning. And we also have Sonobe Sensei from Kyoto University. Good morning.
Assalamualaikum, selamat pagi.
Oh, selamat pagi. Hello, Sensei. How are you?
Yes, baik. Thank you very
Right,
much.
and then we also have Miss Okta Suryani, PhD. Good morning, Miss Okta. Right, maybe our Vice Rector, Pak Rafnaldi, would like to have or greet directly our keynote speaker, Sonobe Sensei. Silahkan, Bapak.
Good morning, selamat pagi, Sonobe Sensei.
Good morning, selamat pagi, Sensei. Thank you very much for your kind invitations, and I'm really appreciate all of you to give me this very wonderful opportunity. Terima kasih.
Yeah, we are also very happy to have you here in our international symposium. So it's a very great time for us to learn many things, especially with the development of research and technology in Japan, especially in the Kyoto University. So we can get some new ideas and also maybe to discuss or share ideas with other parallel speakers in this symposium. So thank you for your participation, Mr. Sonobe.
Of course, from me also, terima kasih, and thank you very much. I would like to also learn from all of you and improve my understanding and scientific knowledge. Thank you very much.
Okay, you're welcome. Thank you too.
Thank you, Bapak Rafnaldi and Sonobe Sensei. We also like to inform you, ladies and gentlemen, that among us here, we also have the Dean of Faculty of Engineering, Dr. Fahmi Rizal, MPD, MT, and then also Dean of Literature and Arts Faculty, Professor Ermanto, SPD, MHum, and also Dean of Faculty of Social Science, Dr. Siti Fatimah. Selamat pagi, Ibu. And also we have pagi, Ibu. And we also have Professor Bafirman from Faculty of Sports Science. Selamat pagi, Bapak. Right. Ladies and gentlemen, we will now have a few minutes, a short break before our distinguished guests and respectable participants of PSTRS, This is the end of the opening ceremony. We would like to express our deep appreciation for your attention. As the master of ceremony, I would like to excuse myself for this session. The plenary session will start at 9 a.m. Before that, we will have a short break for 10 minutes. You may turn off your microphone and camera, but please do not leave the meeting room. Thank you.
Universitas Negeri Padang, established in 1954 under the name PTPG Batu Sangkar. UNP's vision is to become a reputable, internationally recognized university.
Assalamualaikum warahmatullahi wabarakatuh. I am Professor Ganefri, PhD, Director of Universitas Negeri Padang. Welcome to Universitas Negeri Padang.
The impact of technology and the industry nowadays have triggered Universitas Negeri Padang to develop sustainable programs. Universitas Negeri Padang focuses on education and qualified teaching process, research and high-quality publication, then community services that give advantages to the society.
Universitas Negeri Padang has 8 faculties. They are the Faculty of Educational Science, the Faculty of Languages and Arts, the Faculty of Social Sciences, the Faculty of Economics, the Faculty of Tourism and Hospitality, the Faculty of Engineering, the Faculty of Mathematics and Natural Sciences, the Faculty of Sports Science, the Graduate School, the campuses of Universitas Negeri Padang are spread across 7 areas in West Sumatra. Universitas Negeri Padang has equipped facilities and infrastructures such as a main library with digital services, an auditorium with a capacity of more than 8,000 seats, swimming pools and sports fields of national and international standards, and laboratory schools from kindergarten to senior high school.
Hello everyone, nama saya Maria Adeline Doroin. I'm from Capiz State University, Philippines. It's worth to remember and worth to share to the world. Mabuhay UNP!
Other facilities include a medical clinic, international student dormitories, the UNP Hotel, a mosque, a business center, and a teacher education center.
Mega from Myanmar.
We are studying in different faculties at UNP, and we are very proud to be international students here at UNP. And
We love UNP!
In order to improve the quality of its graduates and be an international level university, UNP equips itself with laboratories supported by sophisticated equipment, a center for developing students' soft skills and creativity, as well as adequate practicum and training facilities. The campus of Universitas Negeri Padang also provides facilities for students with disabilities. Some of the achievements made by UNP in the last 4 years are as follows. UNP won the 5th national rank for research and publication in Indonesia, the best work unit in managing the state properties, top 3 national level for social media management, first winner of informative state universities in Indonesia. The rector of Universitas Negeri Padang won as the achievement motivation person from the Information Commission of West Sumatra. Top 10 universities in assisting tourism villages in Indonesia. UNP students become champions at the 28th national level Musabakoh Tilawatil Quran. Universitas Negeri Padang got an award as an informative public institution from the Indonesian Information Commission. Universitas Negeri Padang won First Public Information Openness Award from the Information Commission of West Sumatra. The rector of Universitas Negeri Padang won as an achievement motivation person from the Information Commission of West Sumatra. Universitas Negeri Padang was awarded the top 5 state universities towards informative awarding of public institution information openness at the national level. First winner of National Quality Assurance. Top 2 of services through the internet for state universities in Indonesia. Top 1 of public information openness at the West Sumatra level. Best asset management among 720 work units in the region of Padang. Universitas Negeri Padang won as the best state university as Public Service Agencies Award for the category of activity and budget program. Top 1 at the National Dance Festival. First winner of the Sumatran Regional 1 Robot Contest in Pekanbaru. Runner-up in Energy Saving Car Contest and Best Newcomer. UNP received an award from the Ministry of Research, Technology and Higher Education of the Republic of Indonesia as the organizer of the Energy Saving Car Contest. First winner of the 8th Indonesian Tourism Competition in the category of Tourism Advertising Video. Medalist for swimming at the National Student Sports Week. Top 3 at the national level students Musabakoh Tilawatil Quran. First winner of the critical debate competition in Sumatra. Runner-up of the National Scientific Writing Competition. UNP has also succeeded in organizing national and international events. Universitas Negeri Padang grows and develops with the motto Alam Takambang Jadi Guru.
Right, ladies and gentlemen, while you are having a short break, we would like to invite the head of Research and Community Service Institute, Bapak Yohandri, and then Dean of Faculty of Engineering, Bapak Fahmil Haris, Dean of Faculty of Social Science, Ibu Siti Fatimah, and then Dean of Literature and Arts Faculty, Bapak Ermanto, Bapak Profesor Bafirman, to have a little chit-chat with our keynote speakers. We have Sonobe Sensei here, and Professor Harith, and also Ms. Okta Suryani, PhD. Also, we would like to invite the Secretary of Research and Community Service Institute, Bapak Anton Komaini, and then the Head of Research Center, Bapak Kris Madinata, and also Head of our committee, Bapak Raymond. Silakan, Bapak-Bapak dan Ibu.
Good morning, Dr. Taro. Ohayo gozaimasu, Dr. Taro. It's long time not see you.
Oh, good morning. Very nice to meet you again.
Yeah.
How are you?
Fine,
Thank you
fine.
very much for kindly inviting me. Thank you very much.
Thank you for support our activity and share information regarding to the research collaboration. It's possible to UNP to join research with the Kyoto University. And thank you, Prof. Haris. Thank you, Prof. Haris, to join. It's long time not see you.
Same thing to you, and good morning, everybody. Good morning.
Good morning, Prof. Haris and Prof. Dr. Taro. How are you? Fine.
We are fine. Kuala Lumpur.
Kuala Lumpur. You still UM, Prof?
Yeah, I stay with UM with University of Malaya. I stay in my office.
Yeah, it's long time. Yeah, I think we met 10 years ago when we meeting in the Selangor, I think, with UMPDEC group.
Yeah.
Dr. Taro, how about the case of COVID in Japan?
Of the case has been just increased. It means that the number of the test has been increased. So anyway,
Okay.
I think so that's why the number of the detection has been increased. Yeah, automatically scientific result.
But we don't hear your voice very well.
Okay, can you hear me? Can you hear me?
Okay, very
Yeah.
clear.
Okay.
Providers, you still communicate with the Prof. Nasruddin?
Yes, we do meet quite often because we are research center. We normally have meeting with the Deputy Vice Chancellor of Research and Innovation. So we meet frequently actually, Prof. So we always have discussion. So he is busy. He has really retired. He has really retired about last year, but he's still on contract. So I think Indonesia, I think if I'm not mistaken, as a professor, you can work until 72.
You're right. 70 years.
We are 60. So normally after 60, we are normally given a contract if the university wants you.
So you contract with UM, Prof?
Yeah, I stay on the contract. I have retired about 8 years back.
But you're still director of Photonic Center?
Yes. Presently.
So is still need to quarantine to visit to Malaysia?
Can you please repeat again, sir?
Still need to quarantine.
No. We have opened our door I think couple of months back. I think Japan still have their door closed, if I'm not mistaken. In Malaysia, our door is open, very wide. We like to welcome the Indonesian to our country. You are the most important people in this region because our neighbor, right? Indonesia is a very big country.
Yeah.
They are very dominant actually.
Yeah. Okay. Okay, we can start the what? Mr.
Right, we still have a few minutes. Maybe Ms. Okta would like to greet the fellow invited keynote speakers.
Morning.
Good morning, madam. Good morning to you.
Yeah, good
Good
morning.
morning, Professor.
Good morning, Professor Hals, and good morning, Sonobe Sensei.
Good pagi.
How are you? Yeah. Ohayou gozaimasu.
Your style like scientist, Prof, like Albert Einstein, Prof. Your hair.
Yeah,
you gesture like really scientist like Albert Einstein.
No.
Your hair.
Because just to share with you, we have gone through COVID and quarantine for many months in those days. So never have the opportunity to go to the barber. I normally do my barber at Indonesia. I always visit Surabaya.
Surabaya.
They have very nice barber there. Yeah.
Prof. Harith.
Yeah.
Have you visited Padang, Prof?
I wanted to go this time, because for this conference, but what actually happened, I'm very excited to go to Sumatra because, as you know, Malaysia is being divided. Not say being divided. We have two portions. I come from the northern part of Malaysia, peninsula. Mostly
Peninsula.
all the people from that side comes from Sumatra. As you move towards the south of the peninsula, they come from the Java island. They are all mostly Javanese. So the northern part are mostly Aceh in the Sumatran. I am originally from Aceh.
Okay.
But someday you should visit Padang.
Oh yeah.
Padang is a beautiful city with a
I know.
specific culinary.
In fact, I want to come for this conference, but time flies, because time flies. I wanted to come. So the next thing I know, I was already ready the time was for the conference. If I have more time, 2 months, I would have come to Padang. I would really love to be in your place. I know it's a very beautiful campus and fantastic seafront. Our University of Malaya is right in the city. We don't have seafront. We have seafront, but it's quite a distance. But your university is fantastic. It's a beautiful city.
Yeah.
Okay, for maybe next year you can can visit to our campus because
Yes.
now no flight direct from Padang to KL. I think I try check in the Asia website. I think January next year will direct flight KL to Padang.
Yeah, that'll be great. In fact, I don't mind to take Garuda. In fact, the Garuda flies to Padang through Jakarta. It's always I did went once to northern part of Sumatra many years back, but never have the opportunity to visit Padang. So I think this conference, and I think I got an appointment as an adjunct of University of Padang. It'll be a great opportunity for us to work very closely with University of Padang, because Indonesia is a country to be reckoned with. It will be a superpower. It will be a superpower in a few years' time. We are a small country. Malaysia is a very small country with a small population, not as big as Indonesia. And Indonesia is a superpower in the ASEAN region.
We hope.
Inshallah.
Inshallah. And also we invite Dr. Taro to visit us.
I look at Dr. Taro very busy. I look at in Facebook, you are very busy, Bangkok, Vietnam, Cambodia. I think you have to spend your time to visit our campus.
Yeah, sure.
Yeah.
very much willing to. Actually, I'm now in Bangkok, not in Japan.
Oh.
So somehow a little bit near to the Indonesia and Malaysia. Can you hear me properly now?
Yeah, I hear clear.
Okay.
It's loud and clear, Professor.
Oh, really?
I hope you have a time, and then I want to see you. Our develop one community micro hydro, and and regarding to the energy. If you have a time, you can visit our. If you have time, maybe during you visit to Bangkok, I think you have to 3 days to visit our campus.
Thank you very
I
much.
think you have to once again to our agenda for our campus to visit.
Actually, I would like to also send my very best regard to the Professor Nasruddin.
Yeah.
Oh,
yeah.
Professor Taro, I will definitely inform him that that you send your best regard to him.
Thank you very much, as well as to the Miss Norida too.
Yeah. Oh, these are actually energy people, huh?
Yeah.
Okay. I do not belong to the energy people.
5 years ago, Prof. Nasruddin visit our campus.
Yeah.
We bring him to visit to Bukit Tinggi. Yeah. and also his wife, and they are very excited to visit our province West Sumatra.
Yeah. I think we can. I think I have some of my staff here with me, Dr. Aisha, Dr. Dorina. I think maybe I want to send them to University of Padang for a short visit, maybe if possible end of the year and so on.
Really? We are very appreciate if your team will visit our campus.
Yeah, because we want to find ways that how we can foster an effective collaboration actually.
Okay.
Dr. Chris, Prof. Haris, and Dr. Taro, I think it's time to starting our conference. Can we start our discussion?
Okay.
Okay.
Miss Monica, you thanks.
Right. Thank you for the nice conversation, Sonobe Sensei, Professor Haris, and Ms. Okta Suryani, PhD. We will now proceed with the first keynote session with Datuk Professor Harith bin Ahmad. Dear participants, please be seated and turn on your camera. Get ready to listen to the presentation from our amazing speakers. Before that, allow me to explain or read a brief biography of Datuk Professor Harith bin Ahmad. He was born in 1955 and received his Bachelor in Science in Physics at University of Malaya in 1979. And then he continued to pursue master degree in high voltage technology and PhD in laser technology from University of Wales, UK in 1980 and 1983 respectively. He began his academic career at the University of Malaya in 1983 as a lecturer and is currently the director of Photonics Research Center at the same university. His areas of expertise and research interests are quantum electronics and lasers or laser technology, fiber optics and waveguides or planar light wave circuit, fiber optics and waveguides or fiber optic technology, and he has published more than 520 articles in ISI index journals. Wow. He has supervised more than 30 PhD students and over 30 master students. He is a member of Majelis Professor Negara Malaysia and also a Merdeka Award Nomination Committee. Thank you, Datuk Professor Harith, for making your time for us today.
Okay, thank you so much for the kind remark, Madam Chairperson. Should I start now? First, let me check. Can you hear me clearly?
Clear and crystal. You can start, Professor.
Okay. Can you see my slide?
Yes, we can.
Okay, as you did mention just now, my training was more on lasers. I did lasers many years back, 40 years back, I think so. And I only moved to materials this couple of years because the funding was made available for me. And a lot of this work is being done by Dr. Rina, my colleague. And I'm not an expert in material, just to share with everybody. It's just that I use this material mainly for application in producing very short pulses in fiber laser. My specialty is more on fiber laser now, from laser high power, from bulk solid state laser, I move into optical fiber. Purely on funding, I adjust myself accordingly to the available fund, Madam Chairperson and the audience. I'm quite flexible. I will adjust myself to the funding. So what I'm going to discuss this morning is more on interest of two-dimensional nanomaterial in photonics. It has been around for the last couple of years. It's quite an interesting topic that I would like to share with University Padang. I think I'm very sure you can do work on this area. If you have chemistry lab, I think there are many opportunities that we can do the work together. So I have my colleague, Dr. Rina Yusuf, Dr. Siti Aisyah Ridwan, and Dr. Muhammad Zarif Samion. We are from Photonic Research Center, University of Malaya, Kuala Lumpur. We are right in Kuala Lumpur, right in the city. We are in a city exactly in the Kuala Lumpur, exactly right in the center. And I was before part of physics department, University of Malaya, but now I'm heading the Photonic Research Center. Our Photonic Research Center is equivalent to a faculty, actually. It's in terms of rank. Now, I will give you a very short, brief introduction of University of Malaya, Kuala Lumpur, Malaysia. It's quite interesting to share this slide with our audience, especially from University Padang and also Kyoto University. Our Vice Chancellor did his PhD from Kyoto University, I think in mechanical. Now, University of Malaya is very old, ladies and
gentlemen, extremely old. It started 1905 actually. It's a merger between King Edward, the 6th College of Medicine. It started with King Edward College of Medicine. Our medical faculty is very large, extremely large. They have about 600 lecturers. We have a very big hospital. We have a second biggest hospital in this country. University of Malaya has the second biggest hospital in the country. It's extremely well equipped with many specialists. So historically, we start as a medical, as a King Edward VI College of Medicine. Eventually, in 1928, we merged with Rifles College in Singapore. These two colleges were in Singapore during the early days when Singapore was part of Malaysia. Singapore has been always part of Malaysia in those days. Along the way, we have lost Singapore in some politics by the first Prime Minister. So 1928, we merged those two colleges. And 1949, we have the merging, as I did mention. Then eventually, then along the way, it has been converted. It has been converted as University of Malaya. The name is still the same, University of Malaya in Singapore. Actually. In the early days, you have University of Malaya in Singapore. If I'm not mistaken, they were at the present campus of National University of Singapore. That used to be University of Malaya. So 1962, when Singapore split from Malaysia, so you have that University of Malaya in Singapore break up into University of Singapore. All right. Now it's known as National University of Singapore. Before it was called University of Singapore. And University of Malaya shifted themselves. We took the name, and we shift ourselves to Kuala Lumpur. So University of Malaya eventually relocate in Kuala Lumpur in 1962, but it has an origin of 1905. These are historical development. If you look at the upper part of this slide, this is how the campus, the rightmost, this is our campus. It has a lake. It's very green. The green area of Kuala Lumpur, as you know, Kuala Lumpur just like Jakarta, many high-rise buildings, but this part is green. All right, we are just at the end of Kuala Lumpur, about I think 3 kilometers away from the center of Kuala Lumpur. This is the early days of the beginning of University of Malaya in 1959, the second photograph. Now I will give, I will run through a brief introduction of Photonic Research Center just to share with the audience. It started quite long. Basically, our research started in 1970s. It started as a laser laboratories. It's one of the oldest laboratories in this campus actually. So along the way, we have transformed ourselves into a research center, Photonic Research Center, because we still do lasers and then we do optical fiber. We have a complete facility. We have a complete facility to fabricate waveguide. We used to make splitter for the optical network. We are able to make 1/8 splitter. There are many things you can see our publication. We do a lot of publication on optical waveguide. We work closely with Australian National University in Australia, and these are part of my staff. We have more staff. I don't put everybody here. We have many. We always employ constantly foreign lecturer. We have a very positive policy. We have to employ about 400 foreign lecturers. It's a policy of the university. In fact, it's the policy of the Malaysian government. We require to have certain percentage foreign lecturer. So we have about 400 foreign lecturer, maybe from India, Iran, from Europe, and so on. So we have a mixture of people from the world. We used to have many Japanese in those days. In fact, we have our matriculation is being operated by the Japanese government. Actually, we have a lot of Japanese academics that teach in our matriculation, the A level, before is a pre-university education. Now, my topic I'm going to discuss, I have categorized them as introduction to 2D materials, just to share with the audience, and development of 2D material, and then I'm going to go through very briefly synthesis technique of 2D materials, and I will update you on the behavior of 2D materials, and then specifically we use these 2D materials for photonics application, mainly to be used as saturable absorber, and then I will go through roughly the other application of 2D material. Then I will conclude my talk. Now, if you look in this slide, it's a two-dimensional materials. If you look on your left-hand side, it gives you some idea of 2D materials. It started actually by accident, just to share with everybody. It was started by accident by Novoselov and Jam from University of Manchester, actually. They were doing a semiconductor growing. Okay, they have a fabrication, facilities, growing semiconductor material. As you know, in the British system, British have this culture of tea break. I'm not sure you have this in University of Padang. Normally about 10 o'clock, we go for a tea break for half an hour, and about 3:30 to 4 o'clock, we have another tea break. So what actually happened with Novoselov and Jam, during the tea break, they were just trying to make a single layer material. What they do, they take the graphite block and then they put cellophane tape. They keep on stripping for many days, weeks, and months. Eventually, one day they are able to form a single layer of graphene or graphite material onto the cellophane tape, which now we know as graphene. Is a 2D material. That is the beginning of 2D materials, and everything is history. You find that 2D material is extremely important in modern devices, very important in modern application. What I'm going to go through for this morning will be like we have done many work in all this material. We have done quite a lot of work in graphene oxide, We have done work on BP, is black phosphorus. It's very good material, but it's quite unstable. We also do with TMD, transition metal D-chalcogenide. Then we have this other material is called NBF, if I'm not mistaken, BN, boron nitride, and others. So these are the material we have frequently do in this lab for the last 3 years. You can see our publication for the website. It's quite a large amount, I think about 300 papers just on this 2D material. So normally, if you look at this, material, there are very ways to classify them. Isotropic material, they are normally classified as zero-dimensional. All right, zero dimensional. Okay, and they are normally of a diameter about 10 nanometer. They are called zero. They are normally sphere or cluster or dots. And the next photograph of this left-hand side, on the right-hand side, you have the 1D material. They are like carbon, tubes, wire rod, like CNT, carbon in the tube. And then we have the 2D material. That's what we will discuss for this morning. They are two-dimensional. They are basically two-dimensional. You have X and Y axis. So you can have a single layer. If you are very lucky, normally single layer it can be formed by chemical vapor deposition, but our approach is slightly different. We use liquid phase exfoliation and also mechanical exfoliation. So we do not get frequently single layer. They are normally multiple layers, 4 to 5 layers, right? 1 to 3 atom thick materials, for instance, if you use metal, insulator, and semiconductor. Mono layers normally less than 5 layers, as I did mention just now. But film that you form, if you use mechanical exfoliation as well as liquid phase exfoliation, you get slightly more than 5 layers. If you have more than 5 layers, they are not 2D, they are 3D. They are considered as anisotropic. And 2D material normally exhibit plate-like shape, include graphene and other monolayer materials such as enzene, black phosphorus, sometimes called phosphorine, and also diatomic hexagonal boron nitride. The interesting thing about 2D material, it has strong bonding. They basically have a very strong bonding in the plane. In the single plane, they have strong bonding between the atoms, but they have weak bonding between the plane. If you look at this figure, I cannot use my pointer, my sincere apology. Let me see, I can use my mouse or not. Okay, can you see my mouse? Between this plane and the next plane, you'll find that the bonding between these two planes are weak, actually. They are called van der Waals bonding. So normally we use liquid phase exfoliation and mechanical to remove the bonding between the plates. Eventually you can have a single layer. Now, if you look in the development historical, it's very important to understand the historical aspect of 2D material. These are very important historical development. You find that the discovery of the graphene is about 2004. Then it start a very big drive in after 2004. You find that you have like graphene oxide. Then sometime here is called through the silicon growth, and then you have the development of other materials such as black phosphorus. They are virtually being fabricated by liquid exfoliation method, and then you have boron and antinom. Then you have the various type of the figure, as you can see from this in the figure. And the bottom part, you see they are. We give you some of the structure, how it looks like. The structure of the material has been shown in the lower part of the left-hand side figure. This figure is very important. It provides a timeline of the key steps in the development of elemental 2D material. It's been taken from reference 1. You can always check. And then on your right-hand side, you will see the number of the publication. It's very interesting. In the early days, the number of the publication is not as large. As you move now in time, 2019, the number of publication in 2D material is shoot up nearly exponentially. So it's a very hot topic, very interesting topic, very hot topic. It's being pursued by everybody in the world actually. But right now it's being dominated by China. And then if you look at the right-hand figure at the bottom, it gives you the band gap energy of different material and against time. You find that it start with, give you for example, silicon, graphene, and then you have gallium oxide and so on. So this bottom part gives you some idea about band gap energy. Why band gap energy is very important? Especially for photonic application, we need the correct band gap energy actually, because we are using light. Light comes in different wavelength. If you look at light wavelength, by knowing the wavelength, you can convert the energy because you are causing optical excitation in the material. So the in-depth understanding of band gap energy is extremely important for 2D material application in photonics. Now, just to share with the audience, the 5 top 2D material startup is a very major industrial changes now you find from this slide. There are about 279 startups that we are able to analyze for this talk. You can get from the internet source inside. The 5 top 2D material startup that impart tremendously to the industry is given here. It's called Everclock, and then you have Dance, you have ANL, and so on. And then you find that in the map, you find where these industries are located. In the United States, you find that you have Europe, and then you have Australia. All right, and I'm very sure there are some industry in Korea and also Japan. I am very sure of that, but we're not able to capture that industry in Japan and South Korea for the moment of time. So, for instance, the 5 top startup is Advanced Material Development, is a British-based, English, UK, work on innovative 2D material. Like for instance, Applied Nano Layer is a Dutch company. I think people from Indonesia will understand the Dutch people more than us. It's a very big development taking place in Holland. It applied processes like CVD to manufacture thin sheet of material. It also produces monolayer graphene and 2D material sheet with low defect density. It's very important to reduce the defect. And we have Everclock, that is Canadian. They make 2D material coating on large surfaces, offer a manufacturing platform for continuous large area exfoliation of 2D material with the help of energy efficient method. You have Flexigraph, Australia, and then you have another Dutch company that provide 2D in situ heating solution for transmission electron microscopy. Now, I just want to share with you the family. We are sharing the slide to show you the family of 2D material. So as you know, the early days by Novoselov and Jam from University of Manchester, it started with graphene. You have graphene, that from graphene you have graphene oxide. By using chemical process, you can change graphene to graphene oxide. And then you have fluorographene, then you have boron nitride, and then you have BCN. Then you have another group, is the different part of the periodic table, 2D chalcogenide. You have MOS2, WS2. This we have done this work on all this material. You have the various different type, the semiconductor type, and then you have the metallic. Then you have the MZine. It's very interesting material. Last 1 year, we'll be spending quite a lot of time on MZine, and these are the material under MZine, and so on. And then the 2D oxide, TiO2, manganese oxide, and so on. It's very important to understand the boxes in the right-hand side. Red boxes, it means that these materials are stable at inert atmosphere. So if you want to work on 2D material, it's very important to make sure the material are stable with time. You don't want to fabricate the material that after a few days you cannot use them. So the one in the yellow box, they are considered potentially stable material at ambient condition, and the brown box is material stable at ambient temperature. Yellow box is semiconductor-based material, and the two bottom parts give you the stable material in air and room temperature. All right, synthesis technique of 2D material from this slide. It's very important to understand how to synthesize 2D material. Normally, there are two ways of doing it. If you look on your left-hand side, it's called the bottom-up technique. On your right-hand side, it's called top-down technique. We have explored both techniques, right? Bottom-up as well as top-down technique. The bottom-up technique, for instance, there are various approaches. For if you look, you have chemical vapor deposition, hydrothermal synthesis, pulse laser deposition. These are, they has a pro and con. Chemical vapor deposition allow you to create very stable layer, very thin layer, 1 or 2 layer. It has high quality flakes, but the only problem is when you run CVD, it has a complex parameter control. In the case of hydrothermal, you find you can produce many layers, each of layer controlling, but it needs high pressure and temperature. For pulse laser, is interesting also, but it has complex parameter control. It's up to us which technique we want to use. And on the right-hand side, I have the mechanical exfoliation. That is the method used by Novoselov and Jam by using cellophane tape, peeling them on the graphite block. It's quite simple. It's basically simple, high-quality flakes and low yield, but the only problem you have low yield and poor scalability. Liquid phase exfoliation is cheap. It's just a chemical process. It's simple, high yield, but it has a lot of defect. And then you have ion intercalation method. It's simple, high yield, but leads to structural alteration. So it's a choice of the audience or student and academic, which method would be the best method for your approach to fabricate 2D material. Now, if you look in this slide, I share with you the behavior of this 2D material. 2D film and heteros structure as given to you on the left-hand side. They are normally high quality, they are high crystal quality and homogeneous thickness. They have uniform thickness. But if you move towards liquid exfoliation and wet chemical approach, it has not a very well structured. It has vast specific surface area. There's a disadvantage of using liquid exfoliation and wet chemical synthesis, but they are cheap. I think most people would like to use this because it doesn't cost you very much. If you have a CVD, then you might want to try to use on the left-hand side. So where do you apply all these material? For CVD, they are normally used in electronics, in spintronics, optoelectronics, and solar cell. For the method used like liquid exfoliation and wet chemical synthesis, they are normally being used to produce wearable electronics. They are used in battery, oxygen reduction devices, and also if you look at the bottom part, corrosion protection, sensor, and hydrogen evolution. This one appear in Nature Communication for those who want to read. It's very interesting to understand the process where it's being applied to the different industry. These are different industry. They are there already that slowly expanding and also producing device for mankind. Now, the properties of 2D materials, they are basically high carrier mobility. It has a good superconductivity, mechanical flexibility, good thermal conductivity, high optical UV absorption, strong interaction with light. That's what we want for our work. Optical sensing structure and large surface area. They are excellent substrate for adoption. Okay. My sincere apologies, just now my internet somehow go off. Can you still see my slide?
Yes.
Just now, I have sometime in Malaysia we have intermittent, especially University of Malaya. We always have problem with our Wi-Fi. I hope this thing does not happen in University of Padang. Okay, so 2D material versus the bulk material is very important to understand the different behavior between 2D material against bulk material. The 2D material, you have removed the weak interaction, van der Waals interaction, weak link, then you can form a single layer, and then you have other advantage as increase in the ratio of surface area to volume. Is more sensitive to the surrounding. You can form optical sensor, and then you have the other advantage of confinement of electron in the plane greatly. So compared bulk material, graphene has only covalent bond, and so is extremely strong. In fact, graphene is a very strong material. If you read more about graphene. Now, 2D material that I'm going to go, the one that we use so frequently in our lab is a saturable absorber. Mainly, we are making this device. We are making this device, saturable absorber, to be used in our system, in our fiber optic system, to generate short pulses. Means we want to generate pulses in the region of microsecond. That's normally called or termed as Q switching technique. And then we can also generate optical pulses in femtosecond and picosecond. They are called mode locking. And those are very interesting for industrial application. When you make high power fiber laser, short pulses, you find that there are tremendous opportunity for application. Now, if you look at the left box here, illustrate the crystal structure of multi-layer graphene transition metal dichalcogenic TMDC, black phosphorus, and their heterojunction. And the right box, you find that it lists the typical optical and optoelectronic properties of 2D material. And then if you look at the center figure, it looks like a snake. These are how we coat the material onto the hose. Hose means how do I coat them onto the fiber? So I can use, for instance, microstructure fiber. These are normally called photonic crystal fiber. So I can dope the 2D material in a microstructure fiber, or I can coat the material onto the ends, on the fiber end face, as you see in this figure that shows in yellow and slightly black color. You can coat the material there. And then you can also make a D-shaped fiber, as you see here. Let me find the pointer. These are called the D-shaped fiber. We normally fabricate the D-shaped fiber in our lab. I can show to the staff of University of Padang how to fabricate this material. It's not very difficult. It's quite cheaply done. And then we pull the fiber to make it very thin, very narrow. It's optical microfiber. There are many applications in optical microfiber, for example, third harmonic and so on. Now, I'll just go a bit more on this, how to make the hose, where you coat the 2D material. 2D material integration scheme on fiber is called tapered fiber. If you look on my left-hand side, it has a stages. It has a stages, and normally we have a flame, hydrogen flame, and then what we do, we take the fiber. The fiber are very thin. It's about 1/10 of the human hair. It has a core diameter about 9 micron and a cladding diameter about 125 micron. And then we put the flame at the center part of the fiber, and the flame can move. The flame can move left and right, so that we provide a uniform heating onto the fiber. We provide a uniform heating on the fiber, which we have the temperature been set to soften the glass. It's very important to have the right temperature to soften the glass. You don't have very high temperature. If not, the fiber will melt and you break the fiber. So enough temperature, about 800 to 1000 degrees to soften the glass. And then what we do next, if you look at the two stages on your left and right, okay, you look at my pointer here, this one stage here, the fiber is being clamped here, the fiber is being clamped here, and then at the same time it's all motorized is being controlled. Then you, as you melt the fiber, at the same time you pull the fiber towards the left here and then towards your right here, you pull the fiber. Eventually you can reduce the diameter on the fiber to 10 micron only 10 micron. You can even make nano wire. Nano wire is a very interesting topic right now. It's very interesting for many applications, nano wire. So normally using this flame method, you can make diameter as low as sub-micron, okay? So if you look on my right-hand side, I started with the fiber. The fiber that you can buy from the market is quite cheap. It's about few cents per meter, extremely cheap. And then you use flame, you soften the glass, and then you pull the fiber left and right. Eventually, the fiber will form necking. It's smaller if you want to, but it's very fragile. And then we take the material, the 2D material solution. You can do by drop casted method. You coat onto the tempered region. These are called a tempered region. You can coat them. So what actually happens? The material surround the tempered region. So what will happen now? If I have a light coming from my left, if I have a light, a signal coming from my left, then the part of the signal will travel in the environment. These are called effervescent field. It's called the effervescent field. It will travel in the environment and then it will interact with the material. It will interact with the material. So what will take place as the light intensity is low, it will get complete absorption. As the intensity increases with time, then you find that the material cannot absorb anymore, then it will open up and the light will just go through. By this simple principle, we can generate short pulses like Q-switch technique and mode locking pulses. Okay, these are the actual experimental part we have in the lab. Just give you some idea. We use some of the stages. This method is different. The early slide using motorized stage, we make microfiber. Here we cut the fiber. We cut the fiber by using a motorized wheel. That eventually we touch the fiber. Eventually we cut to a certain shape, as you can see on your right hand side. It cuts a shape, and on top of this empty space, we can coat the 2D material onto it, so that therefore the light travels here will interact with the material. It's very important to find ways such that the light will interact with the material so that you have optical absorption taking place. If you look at my mouse, you find this how it looks like. We cut the shape from a circle into half circle, and the yellow part is the core. The core is still there, and the material are being coated, just touching the core. Now, the other method that you can use in University of Padang or anywhere is very simple also. It's called a thin film. Thin film is, these are early days being demonstrated in last 10 years. Normally people use thin film. They dope the 2D material into a polymer. The polymer is your choice actually. Normally we use PVA as our polymer host. So we dope the 2D material in the polymer host. So if you look here, these are very detailed slide we show to you. It's done in our lab. Form the material. Eventually, we form the polymer, and then we have a very thin film, a very thin film that we cut as small pieces that would be put on top of the optical fiber ferrule. This is a connector, the optical fiber ferrule, and then we sandwich with another connector that form like a sandwich the film in between two connectors, as you see on your right hand side. We have an adapter, then you have the connector, and the film is here, a very small piece, hardly 1 millimeter cross section. So these are normally classified as the solution casting technique. The polymer hosts that we normally use in our lab are PVA and PUO, or you can use chitosan. Now, thin film can also do through mechanical exfoliation, as those being done by Novoselov and Jam during the days when they discover graphene. They're just using a Scotch tape, as I showed to you, a Scotch tape, and then the materials are being placed in between the Scotch tape, and then you peel one side of the Scotch tape. Eventually, you do many times until you get a layer that you barely can see, and that is a single layer or few layers of 2D material. And then you can use this single layer, put at your optical fiber, as you can see on the far end of my right figure, right? I hope I have enough time. So mode lock pulse laser, I will run through because you can read my slide. So these are the steps as I explained how we make the 2D film, or through exfoliation technique through tapered. So normally we have optical cavity. We use thulium dope fluoride fibers. Okay, my time is up. I will speed up. Give me about 2 or 3 minutes. And these are typical optical characteristics of mode lock pulses. You normally have a Kelly sideband here. Okay, and then these are the Q switch that we have. I will just speed through. And then these are optical modulator. I don't have much time to discuss on optical modulation. It's very important, using 2D material for optical signal processing for communication, like driverless vehicle and so on. And then these are the photo detector which we do in our lab. We also do work on photo detectors. And then optical fiber-based biosensor like dengue. I think you have dengue in Indonesia. You can detect dengue using 2D material actually. And my conclusion for giving me the time is 2D material is very interesting, very not that expensive to undertake the research. It has many opportunity, and it allow you many publication if you are interested in the publication. And then it has many opportunity for startup and many opportunity for the academic to move into the industry. So thank you very much for the time given to me. My sincere apology for taking a bit more time than being allocated. I can take questions now. Thank you so much.
Right, thank you, Professor Harith, for the amazing presentations. I do agree that 2D dimensions materials is very interesting. Right, now it's time for our participants. I will invite you all to join Q&A session with Professor Harith. Please use raise hand feature if you want to ask the questions directly, or you can type the questions in the chat room. Thank you.
I think it's a comment here, Amanda. Slide presentation are not available on the screen. Okay, do you see my slide just now?
Yeah, I saw the slide just now. There is no problem with the slide presentation actually.
I think
may I ask question?
Our student don't have question.
Right, wait. We have a participant asking question here. Silakan,
Yes.
Bapak.
Yeah. Thank you, Miss. and Prof. Dato Harit. I have a question. I know that photonic is a good science, and we feel in their life the benefit of photonic, but I think not of all of us realize that this is all of the positive impact of photonics right now. But I think I always ask in my mind, Mr. How does measuring object use like work? Because in my field, I'm from civil engineering. There is a measuring tool using like. I want to ask you, did you reset out there, or maybe you can tell about it, how to measuring tool using like, Mr.
Can I just repeat your question? You want to know how to measure light or what?
Measure tool using like, because I think photonic is about like, Mr.
Yeah.
Like, and then in my field, I'm from civil engineering.
Yeah.
Today, there is a tool how to measuring like.
Nursery. I mean, measuring.
Measuring.
Is it measuring? Am I hearing it correct?
Like laser, or like if we want to know about the leg of something.
Or the leg.
Yeah, the leg of something.
Okay. Yeah, various method, sir.
Yes.
Actually, if you look at the war that's taking place between Ukraine and Russia, a lot of their missiles use laser. Actually, it's called smart system. So the drones use laser. Most of them have used laser. Is to measure the distance of the target actually.
Yeah.
So how do they measure the distance of target? It's called LiDAR. So light is being sent in pulses. The light are not CW, but in pulses. So when the light is being emitted from the system, it will start the clock. It will start the clock actually. And the light will go through to the end of the object, the target, and then it will be reflected. It's normally scattered. And then part of the light will travel back to the photo detector, and that will switch off the clock. And by counting the cycle of the clock, you can calculate the time, okay? And then you know the speed of light. You can calculate the distance of your target to your missile system. That's how people do in most of the war now, because to fire missile without hitting your target is very expensive. Missiles are very expensive. They want to make sure it reaches to your target. So they use laser. And then you may heard that now in the future there'll be driverless vehicle. They use lasers. They use laser to control the car from satellite to control the car. So all this laser, and the other interesting application about laser now coming up very well is medical surgery. Medical surgery. When you operate a person using laser at 2 micron, at longer wavelength 3 micron, you can cut your tissue without having excessive bleeding. So sometimes people bleed and they can die due to excessive bleeding. So instead using knife, they can use laser has changed our life, sir.
Maaf ya. 35 ya? Ada 5. Uangnya dapat? 2.500.000. 25 juta. Kalau lulus.
Sorry, I'm sorry. Let me handle that.
Okay.
Did I answer your question, sir?
Yes. It was incredible. Thanks, Mr.
Right, thank you, Prof. Harif. Terima kasih, Bapak Syaiful. Terjawab ya, Pak, pertanyaannya, Pak?
Yeah.
Right, now we would like to invite another participants. If you have any questions, please open your microphone and start asking the questions directly.
Halo, Miss Monica.
Right. Silahkan. Ini dengan Ibu Ana. Ibu Ana menggunakan fitur raise hand. Please, Bu Ana, you can say your questions directly.
Okay, thank you for the moderator. And first of all, I want to say appreciation to Professor Haris Khalid for your insightful presentation. Here's the question that I want to ask. In the past decades, there's like a ton of publication that are being published regarding of the nanomaterials or nanotechnology and etc. And in your perspective, what is like the most effective way to produce this two-dimensional materials? For example, the photonic materials, and probably it can be in the cost-wise or the most efficient one. Thank you.
Okay, if you want, I can put you in contact with Dr. Rina, because she's a material person. Normally, she do liquid phase exfoliation actually, because the process are straightforward, is rather inexpensive, and I'm very sure you can do similar thing at your laboratory at University of Padang. It's very cheap. It's inexpensive, which you can fabricate easily. It's not complicated. But you write to her. I'm very sure she is more than willing to help you how to fabricate the material. But if you want to talk about optical cavity, I am very keen to help you. Because the most important thing, as I did mention earlier my talk, it's very important for Malaysia to collaborate with Indonesia. Actually, they are the future.
Okay, because like some researchers are struggling with the devices or the financial and etc. So maybe collaboration will help probably. Thank you so much.
But I want to, if you want to come to University of Malaya, we welcome you. We do not have any restriction for any Indonesian academics or student. We have quite a number in those days, Ibu. I have quite a number from Surabaya, and they come here and use our facilities. We are very open. You can use our facilities, and I have people to help to train you. If you like to come, you are most welcome actually.
Oh yeah, sir. Probably last question, I guess. Is there like any possibilities that our students or lecturers that currently wants to pursue their doctoral degrees in University of Malaya, is there any change with your laboratory or the University of Malaya itself?
Yeah, they are most welcome. As I did mention, if they want to take a PhD program at University of Malaya, we have no objection. If they have their PhD program at University Padang, they want to use our facilities, they are most welcome also. Because sometimes you want to set up the same facilities, it takes many years, and it can be quite expensive. And the English people say, working smart. We have the facilities, you can use it. So you can start your work immediately without reinventing the whole process.
Okay. Okay, thank you, sir. Thank you so much for your kind answer.
All right. Thank you. Bye-bye. And do take care. Have a nice day, Madam Chairperson, the moderator. Thank you.
Right. Thank you, Miss Anna, for the questions, and thank you, Prof. Khalid, for Prof. Harith for answering the questions. We still have a few more minutes. Please, we still invite participants. Should you have any questions for Professor Khalid? Professor Haris, I'm sorry, I'm getting wrong again.
Hello, can I?
Yes, please. Ini dengan, silahkan Bapak langsung memperkenalkan diri.
Halo.
Ya, sudah terdengar Bapak, silakan.
Okay, thank you. So, hello, Professor.
Yeah, I am okay. You have a German name, no?
Yeah, I was born in Germany, Prof.
Yeah.
So, greetings, Prof. My name is Dieter Madiawan. I'm a lecturer of mechanical engineering in UNP. Actually, I just joined this year. So, maybe I want to tell a story first. So, when I was studying master in University of Indonesia, I got opportunity to do like short research in Sunway University under supervision of Professor Saidur Rahman.
Yeah.
It's just a 1 month research, and I was asked to do synthesize with the magazine, titanium carbide magazine.
Yeah.
So I have two things that I want to tell. So the first one is, do you have experience in using magazine, and if yes, what method are you using generally? In Prof. Saider research lab, we use hydrofluoric acid to create magazine to remove its Al, because we know that magazine is from max phase, and to remove the Al, so we use high acid. And from my perspective, this is quite a risky method because we are using a high level acid of solution. And for the second thing, that it's regarding the thin films that you showed me, I think this is really interesting because right now I'm working with composite, usually with PVA, bacterial cellulose, gambir, and etc. Usually we do the characterization here, like tensile strains, TGA, and same morphology, and sometimes like we measure the thermal conductivity. So the things that we only do is only the characterization, but we kindly confuse what application can we use. So after see your application on the photonic, I think we can do small collaboration here. We have equipment here such as sonication prop, homogenizer, oven, and etc. So maybe we can provide you the material. That's all, Professor. Thank you.
Can you call Rina? As to come gently. Okay, Dieter, I want to answer you. I'm calling my staff, Dr. Rina. She should be here in a few seconds. Dr. Rina, you may want to take this question. She did not use hydrofluoric acid because it's very bad acid. Very bad. The acid will get into your bone. So we use other method. Maybe she explained to you, Rina. Enzine. How do you?
Oh, actually, for vaccine, we already tried both method actually using hydrofluoric acid and also HCl with lithium fluoride. So
LEF.
Yeah, we tried both method actually, and we found that HCl can give the same effect as we use HF. So that's why when we repeat again the experiment, we use only HCl with lithium fluoride and not HCl. Yes.
Okay. Thank you, them.
And she wants to collaborate if you, because they can make material for you. And this, we have a lot of the material, but we do not have a chemistry lab here because we are the photonics. So we ran the chemistry lab from the chemistry department. So they have everything. But I'm very sure Dr. Rina will be open for collaboration if you have the sonicator. But if you want to ask her more, I think best to talk to her because I will not be able to answer very well on that question. Collaboration.
Collaboration material. Okay. The latest material we have is magazine. We process it from max phase and make it magazine. And also we have other 2D material like transition metal, dihydrogenide. And we can also process our own graphene outside actually. From graphene outside, we can make composite with other metal or metal outside. So for now, we, like what Prof. Ari said, we ran a chemistry lab to process all our material. So it's good if you can provide us, if you have your own chemistry lab, wet lab, or clean room, maybe we can make a collaboration together.
But we can provide you like the materials, so we can prepare it. But right now for the I don't know how do we send to the to your lab, because I think it will be hard for it will make.
I think you can send by post this.
Yeah, but I need to think away how to make the sample is okay.
All right.
How to make
I want to suggest to you, because you are material, you can make the material for us. You have the facility. You can talk to Dr. Rina. Maybe you can send your email to her. You can write to me and I can forward to her. My email is Harith, HARITH @um.ed.my. I can forward to her. Because if you can make the material, we will run the experiment for you. We have people, we have very good facilities of optical fiber. We run the experiment, we can have joint publication. Maybe we can have 4 or 5 publications.
Yeah, wonderful. It's really nice.
Actually, we received sample from our collaborator from India. Actually, they just post it to us, and then we process it, make it into filler, and do the laser pipe here. So actually, you can post it using the normal post actually. Normal service.
Sorry, madam, can you repeat again?
Recently, we received a sample from India.
Oh.
And they send the powder sample to us, and we process it here and do the laser pipe here, laser application here.
And then ask them to categorize.
Oh yeah, I think that way can be efficient too. So then you about mixing onto the PVA, you will do there.
Again?
To make the thin film.
Yes, we will do here, but for characterization, you need to characterize it and send to us so that we can put in the paper.
But Dieter, if you can do that characterization, is so much better for us.
Okay, Prof. Maybe we will do we need more time to think about what materials is interesting for the botanic, Prof.
Okay.
Okay, thank you, Prof. Thank you, Madam.
Right, thank you for Mr. Dieter for questions, and it's very delightful for me to watch the interesting discussion, and we look forward to further publication and collaboration between Dieter and Prof. Harith in University of Malaya, and also with Dr. Rina. Right, and we're also glad to hear that Prof. Harith mentioned University of Malaya is open for PhD applicants from Indonesia, and we look forward to hearing some of our lecturers going to University of Malaya to pursue doctoral degrees. Thank you for your time, Professor Harith, and closing this session. As a token of appreciation, the committee would like to present a certificate to Datuk Professor Harith Ahmad. We hope you kindly receive it. So, since this is a virtual conference, we can only give it virtually. So the certificate will soon appear on the screen. Right, so Professor Harith, this is a certificate as a token of appreciation for your time and contribution as keynote speakers on the 4th Progress in Science and Technology Research Symposium 2022.
Thank you very much, Madam Moderator. I really appreciate. I'm so excited with this certificate. I will appreciate if you can send through my email. There's more useful. And thank you for giving me the opportunity. I just want to ask you, can I leave after my talk? Can I leave or?
Can I have something on? Can I just leave from? Can I leave the conference?
Right, sure, Professor.
You can. Thank you.
Okay, thank you very much. Thank you for your
You are
time.
very welcome. You are most welcome.
Thank
And have a
you,
good
Mr.
weekend.
Hari.
Right? Bye-bye.
Yes. Bye, Professor. See you. Right, ladies and gentlemen, we are now preparing to start the second keynote sessions with Dr. Taro Sonobe from Kyoto University. Hello, Sonobe Sensei, ready?
Yes.
Right.
Thank you very much. Can you hear me?
Still low in volume.
Can you hear me?
Better?
Okay.
It's
Thank you very
better.
much.
So, right. Before we start, please allow me to read the short biography of Sonobe Sensei for a while. Ladies and gentlemen, Dr. Taro Sonobe is a research administrator and sub-leader of the international group at Kyoto University Research Administrations, abbreviated KURA, which the office is in Kyoto University, where he has been working as URA, or University Research Administrator, since 2007. Currently, he is also a member of Provost Office and International Strategy Office at Kyoto University. He has also served as Deputy Directors for Kyoto University Asian Center in Bangkok, Thailand, as well as Kyoto University European Center in Heidelberg, Germany. During 2008 until 2012, he served as Global COA Assistant Professor at Graduate School of Energy Science of Kyoto University. He received his PhD in Energy Technology from Joint Graduate School of Energy and Environment, abbreviated JGCESEE, in Thailand in 2007. In 2019, he has been appointed as a leader for promotion under the Planning Committee of International Network of Research Management Societies, abbreviated ENORMS 2021 Hiroshima, and generated the awareness of capacity development for research management and administration in the Asian region. Recently, he has jointly initiated the project of series of 7 online webinars on science, technology, and innovation coordinators in Japan and Asia towards grand challenges in collaboration with the Asian Foundation, JASTIP, and the Science and Technology Division of Asian Secretariat from August 2020 to March 2021. This joint project has greatly generated the mutual awareness of developing STI coordinators and their network in Asia and Japan. Wow, you have a series of accomplishments, Sonobe Sensei. A lot of accomplishment. And I believe you have been travel a lot, right? Right now you are in Thailand. Yes. And I saw the facts of file of Kyoto University and the website, and I feel very amazed by the historical development of the university. And as I learned, in Indonesia, you have Kyoto University has international office, right?
Yes,
Yeah.
Our Center of the Southeast Asia have
Yes.
the office since more than 60 years ago.
Right, we have a joint Master of Science program with Universitas Gadjah Mada, right? And then one of the international office is located in Makassar, if I'm not mistaken. Right. We look forward to have a joint master degree possibility in the future with Universitas Negeri Padang. So we look forward for it. Now, Sonobe Sensei, whenever you're ready, you can start the presentation.
Okay. So. Okay.
Right.
Okay, so can you hear me properly?
Yes, I can hear you.
And also, can you see my presentation file as well?
Yes, the presentation is already on the screen, but maybe I would like to remind you, Sensei, you can maybe speak up a little bit.
Okay.
Just in case.
Okay,
Right.
Can you hear me? Okay.
Oh, better now. Thank
Okay.
you.
Okay, so Assalamualaikum. And selamat pagi. Thank you very much. First of all, I would like to express my really sincere appreciation to all committees of this special wonderful conference, particularly Dr. Lemons, and then vice rectors, and also Dr. Chris and your madam. And also, I'm very, very happy to meet today's keynote speakers, such as Professor Hari, and Dr. Oker's this opportunity. This is, I think, a very important year's achievement to get together, to know each other by using this special opportunity. So thank you very much. And then today's with the your main topics on the green technologies. I would like to a little bit talks bit different aspects of from the Professor Harris. My topics is on science, technology, and innovation coordinators, STI coordination. How to coordinate green technologies and applied science for better futures. So because I learned from the objective of your conference, there are many participants from the different academic field. And then not only the researcher and the scholar, but also students and administrators. So I'd like to share my personal experience since a student and then researchers and the current state of research administrator, namely STI coordinators. So I started kindly introduced by the Madam Monica's, my CVs. I started my special professional academic background since 2004 in the field of energy and the environment. And then first started from the energy and the environment and the material science. And then when I was a researcher, become the researchers, postdoctoral researcher at the Kyoto University and the assistant professor at the Kyoto. I increased some of the interest from the energy and the environment into more biodiversity as well as bioresources. And then after 2012, I changed my profession from the researcher to the research administrator, namely STI coordinator, to coordinate the wider research projects or academic projects, and just not only energy and environments, but also more including the disaster preventions or bioresources. I saw the committee names of the Professor Junji Kiyono. I think he is very professional expert in the field of disaster prevention. So today's my talks consist of three main topics. One is, yes, so you are interested in the green technology. So I would like to study what is the trends of the green technology for this conference. And the second, what's the role of science and technology? I would like to discuss with you. And the third one, ASEAN and Japan challenge on STI coordination. So this three, I would like to discuss with you, and by sharing it's kind of my thoughts based on my personal experience. So first, let's say green technologies. So as you may know, COP 26, this is about the United Nations framework for climate change. Last year, they had special meetings at the Glasgow in UK to accelerate the progress on reducing the carbon emissions and keeping the global temperature rise below 1.5 degrees Celsius. Then that year, they emphasize on green technology, which will be taken center stage as a conference and economic conference in last years. With that kind of the results, Glasgow breakthrough, they initiate declarations. Under that declarations, Glasgow breakthrough were focused on scaling up green technology in the area of agricultures, hydrogens, renewable powers, renewable energy, and road transports, and steel, that kind of heavy industrial production. And also, probably many of you are using the Microsoft. One of the very famous guy, Bill Gates, initiates the one new financial incentives, namely Catalyst. They try to mobilize investment for direct air captures, green hydrogens, long duration energy storage, and sustainable aviation fuel. This will be created by Bill Gates. These are the kind of the world trends, latest world trends. And also in Japan, The Japanese government also initiates one of the strategy, namely carbon neutrality by 2050, mainly by Ministry of Economy and Trade and Industry, METI. And then that's under the agency, namely New Energy Development Organization, NEDO. They set up the 40 priority fields of which implementation plan have been formulated within the green growth strategy, including energy-related industries such as wind energy or hydro energies, or even some kind of the nuclear technology as well, and transports and manufacturing, including the automobiles, ships, or aircraft, so on. And then third, home office related industries, for example, zero emission buildings or such kind of a thing, lifestyle change. So these are the key priority areas under the carbon neutrality by 2050 under Japanese strategy. And also probably we would like to consider what is the image of green technologies. I think you can also do same thing that I just put green technologies into the Google image, and you can get this image. So green technologies means, or many people consider that some kind of the energy. You can see some green plants or earth, or combine the technologies with the plants, greens, such as renewable energies. So many of the image or ideal image of green technology is kind of the hybrid system with advanced technology and environment, and good for the plants. This is one of the common image, I think. Then what is the definitions of green technology? This is one of the examples, and I took the example from the website of the green technology. This is one of the organization in US. The definition of green technologies encompasses continuity evolving of method and materials from technique for generating energy to non-toxic greening product. This is one of the example of the definitions of the green technology. And probably this can be tailor-made for each region. For example, for Indonesia, for ASEAN, for the region, even Japan. Then more primitively, what is the means of the green? So you can Google the etymology, the word of the greens. I think that there is a social scientist, linguistic person, or a student here. So I think you are more good the knowledge about such kind of a definition. So first definitions of green is, all of you know, green of the color of living plants in the reference to the plants. I think this is more like the related to the environment, environmental conservations, or environment friendly. But the second one, I found a very important meanings of the greens. That green also include the meaning of growings, livings, vigorous, also figurative of the plants. So this one, including the itself, the developments, the growings. So green itself have the very important philosophic words, the meanings. So I think the Indonesia case also can consider more precisely or tailor-makes or customize. What is the meaning of the green for the Indonesia, for the ASEAN, for this region? So just by taking the one word, we can think about more deeply. What is the meaning of the green? What is the context of the green with your culture? So next, I'd like to go to the more what's the role of science and technology. So please stop a while. Let's consider together. What's the essential role of science and technology? What do you think? Yes. So first, I would like to start from my experience on the research of the students. and I would like to show some of the examples of the what do you say, trials or experience in studying about the science and technology when I was a student and a researcher for your reference. So about green materials, green technology. So first of all, there are many approach, a diverse approach, various way to approach to the green technology. Just not only the material science, just not only energy science, but also from the social science or other civil engineering or anything around. You can relate, use fundamental research with more wider visions of the green technology. For example, myself, I studied mainly two large fields. One is the green material science and the processing, including the semi and superconducting materials, which are quite related to the previous keynote speakers, Professor Harris, and also study about microwave heating technology. Other examples was green energy technology. I study about the biomass energies, the conversion of the biomass to the energy or fuel. So I would like to introduce very briefly of these kind of the research activities. The first about the fundamental research on this green materials. For example, fundamental science research for superconducting materials. That kind of the research can be also related to the green technology. So this is a very fundamental research to synthesize this kind of the high temperatures superconducting ceramics. But there is one family of the so-called the yttrium oxides. One of the exception, those family have always shown the superconductivity, but if we substitute one material to the praseodymium, that material cannot show the superconductivity. So we study what is the mechanism of the that's called the origin of the superconductivity by synthesizing this material and then putting some of the model, so-called percolation theory. So this is also one of the very fundamental, but that kind of the material can be used for the superconducting material for zero resistivity. A second example, this is also fundamental research for wide gap semiconducting material, zinc oxide. Coincidentally, Professor Harris also introduced about the photonics materials. I also had some huge experience in studying about the photoluminescence of photo materials target on the zinc oxide. We analyze about the, let's say, electric transition or band structures of the zinc oxides by giving some of the treatments, microwave heatings, and then preparing some localized energy gap. Then we analyze that kind of the electric properties, let's say band gap, by photoluminescence, irradiating lasers and detecting the some of the emissions from the materials. And then we analyze what kind of the model, what kind of the band gap has been created by some sort of the treatments, and then get the scientific results and then combine or let's say compare the model and then try to understand what is the electronic properties of the zinc oxides. This is also very fundamental research, but can be related to the wider good high performance of the photonic material. Okay, second one is more like the applied science research for microwave heatings. Microwave is quite familiar for your life. When you need the hot food, you can use the microwaves anywhere. But the microwave can selectively and rapidly heat up some qualified solid material as well than a conventional heating method. And then these one can be applied for the several applications for material food, organics, in organic material as well, ceramic as well, and woods, pyrolysis of the woods, drying as well. And also we can apply the microwave to generate plasma from the atmospheres or materials, or even for the medical purpose. These are the one of the very fundamental or well-known technology, but can be utilized for many purposes in order to reduce the energy consumption and the time. So this is a very, very famous professor from the University of Malaya, Professor Nasruddin. And then actually 2011, we had a joint symposium with Professor Nasruddin on the first conference on clean energy and technology. Yeah, I had also chance to introduce a microwave material processing for green technology. So this is just pay my respect to the Professor Nasruddin, and Chris, please send my best regards to the Professor Nasruddin.
Thank you. I will send it.
And also, about the application of the microwave heatings, this is kind of the interdisciplinary research. My background is material science as well as chemical engineering. And we collaborate with the engineers from the electronics research, let's say, electric engineering or wave transmission engineering. So this is a very, very normal conventional microwave heaters, but for the scientific reason, we developed this kind of system to generate a microwave, to guide the microwave and concentrate or control the microwave electronic fields into the disk cavities. And then we apply to heat up the titanium dioxide to reduce or remove the oxygen. Then we could achieve to get the plasma. It means this plasma consists of the oxygen. And then these of the titanium dioxide could be reduced to this black phase and also well synthesized, sintered. So it means that we could reduce the metal oxides and also well sinter this ceramics into more and more very strong this field. So, and also just it's 1 minute, we can achieve this kind of the process. So, and also the microwave can all apply for creating the visible light active photocatalyst. This one is the titanium dioxide. You can also the conventional microwave heating, and then this catalyst material can increase the rate of chemical reaction and its property. And also it depends on the energy band. So this is a general, I think for environmental cleanings or even the sun resistance or something, you are using the titanium dioxide as for the photocatalyst or cleaning the air or producing the hydrogen from the water itself. But this titanium dioxide itself can be active only the ultraviolet. It's a very UV lights only. But in order to utilize the more wider range of the lights from the sun, we need to improve this band structure to be more sensitive to the visible lights. So we could synthesize the carbon modified titanium dioxide by using a microwave heating and then install the several band gap. And then that titanium dioxide could be visible lights the active titanium dioxide to show higher activity of the photocatalyst. So this is also one of the applications. And then you can also utilize this kind of microwave process. So next, I would like to introduce to the green energy technology. So this is also very really the different aspect, but I conducted this research in Thailand about biomass energy, biomass or biomass conversion, pyrolysis of the biomass. Biomass means you are familiar with rice straw, or agricultural waste, corn cob, or rice husk, or even these kind of the agricultural waste considered as a biomass. And then these one can be carbon neutral itself. So because this one plants naturally absorb the carbon dioxide for their growth and capture the carbon dioxide as a form of the plant. And then that's why that is one of the sustainable cycle of the carbon dioxide capture in the plants. So by using the actual these kind of the plants of the biomass, in the net, we are not going to emit the positive carbon dioxide in the theory. But in order to well utilize this raw material, we need to study very fundamental characters of biomass pyrolysis or some kind of combustion process. So this is an example. So very, very fundamental, but this one target for further application of effective energy conversion of this raw material in ASEAN or even Thai or Indonesia. And also, this is also probably related to the Indonesia case. You have a lot of the abundance of the coal, bituminous or even the lignite. So we also apply the biomass to make the more clean energy utilization of the coal. It means the combustion of the coal and the biomass to reduce the consumption of the coal and reducing the emission from the coal. So then just not only the mixing, one of the scientific interests, are there any better or synergetic effect? Not just on the mixing the coal and the biomass, but also if we mix the coal and the biomass, if we could get some positive reaction, it could show more good incentive for investment for the future this plants. So we discovered there are synergetic effects between the coal and corn or biomass. So this is also fundamental, but can be utilized for designing the future green technology, green process. This is an academic result. But we need to think about a little bit from the macroscope view or bird-eyed view. We have to really carefully think about the two phenomena, even in Japan. One is the science research in silo. In Japan, many researchers, there are many researchers. Therefore, there are many number of the academic society in Japan, more than 1,200 societies in Japan. And many researchers, yes, they're happy to study their own research in their own field or even this research. But it looks like this figure and many governments research itself note this would be a little bit problem. So this is one of the norm. And the second one is the histories of the science and technological developments. It's about the massification of the science. This is one of the words from the philosopher, Mr. Ortega, about 100 years ago. Massification is a little bit serious at this very advanced era as compared with 100 years ago. Why? This is an image of the massification of the science. X line is a kind of a history. The C is the 17th century, 18th century, or so on, and the current centuries. And then y-axis shows the energy level. So you can imagine about the 17th century, only the Galileo Galilei, for example, they are very much concentrated on the science or even arts or scholars. But maybe other citizens are not much near to the close to the science activity. So that's why that kind of scientific activities are really high energy position, or let's say. But through the innovations or technological developments, the science come to near to the citizen. And then surprisingly, about the 19th century to the 20th century, there was the industrial revolutions, mechanization, that gave the good opportunity for the citizen to utilize the advanced technology. But through these revolutions, they show the kind of the innovation as a form of the like the photoluminescence, and then show the benefit, revenue, and the convenience for the citizen. So citizen require this kind of benefit, revenue, and convenience from the technology. Then even now, this 1 year or 0 years old children can utilize very, very sophisticated artificial intelligence mechanics, supercomputers. So these are the realities of the science and the technology for the society and the community. So now, what is the essential role of the science and technology? As I mentioned before, that historical evolution, is that innovation bypassed? No, yes, it is also, but what is the essential role is creation for the futures. This is come from actually one Kyoto University philosopher, Mr. Iwao Koyama, but creation for the futures, just not only for the next 2 years, but also maybe another 50 years for the generation. That of the thing also very important. So also it is also important to make a balance for the futures innovations, for creation for the futures, as well as innovation for the current stage. And then also, next more important thing is, what is the source of creativity? This is the yours. This is the yours emotions and the spirits and the sense of interest and intuition. So this is not only the matter of the researcher and the professor. This is can be also surely matter for the students and the researchers and the administrator and the professor and the citizen. So the ones of emotions, and the spirits and the sense of the interest and the institution and the motivation are the source of the creativities, which also mentioned by the one of the philosopher or mathematician, Kiyoshi Oka. Oka is a difference from the next keynote speaker, Kiyoshi Oka. So now I'm shift to the more other fields. I think the two contribute to the such kind of the very complicated societies. We need more holistic approach, holistic scientific research approach, and then not only the laboratory, but also need to connect with the practical, real society. And then I would like to introduce one of the tradition of the Kyoto universities. Kyoto University's tradition is field work. We started this tradition since more than 60 years ago, and we established the Southeast Asian Center in Jakarta, 1970, in Bangkok, 1965 or 7. And then we Japanese, many Japanese researchers from the not only the social scientists, but also medicine, or agriculture, or forestry, or engineers. Develop Japanese Southeast Asian area studies. So this is based on the field works, and then this is also based on not the transfer the one knowledge one side to the other. Basic philosophy is to collaborate at the same let's say the equal partnership and co-creation together with each community. So this is one of the philosophy of the Kyoto University's field works. So with this sense of the Kyoto Universities, I would like to show last topics, ASEAN and Japan challenge on STI coordination. So this is the letters of my experience until now. So what's the profession of STI coordinators? I think today it's one of the head research services or your centers. That one also somehow related to the STI coordination. STI coordinators calls as, for example, research administrators or research managers or research development coordinator, for example, anyway around. That ones sometimes provide these supports for developing the research projects or managing the research, consisting of pre-awards and post-awards. And here it looks like a ghost. Sometimes research administrator play as ghost writers for grant application for the professors or for the other stakeholders to get the good research grants. And then just not only getting a good research grant, that ghost writer sometimes become the ghost PI, a ghost secretariats to support the research project. These are the one of the ecosystem of the research, science, and technological innovation ecosystem. Probably you may know reality, but these ones are always not visible. So this is one of the reality, I think, in the ASEAN country. And then what the difference between the scientists and STI coordinators? Left-hand side show the scientists, the right-hand side showing the STI coordinators. And then we make some of the figures about the academic disciplines and academic depth. For example, a scientist, they, based on his or her specialist academic discipline, they will grow or develop their capacity from the deeper direction, deeper academic intelligence in his or her academic discipline. This is a way or direction of the capacity development or of the scientists. For example, in the contrast, STI coordinators have more wider discipline from not only the academic discipline, but also practical discipline to the academic discipline, not only limited academic discipline. So they try to increase the capacity from the wider perspective in both a practical and academic discipline. So these are the little bit difference characters, but either way is very nice and necessary for the society, but probably it depends on the character of the humanity or yourself and myself. And then what's the role of a STI coordinator among the scientists? This is also an implication from the easy mathematics, scientific knowledge. So there is two waves, sharp waves, representing to the two scientists, A and scientist B. For example, engineering and social scientists, or even the material scientists, laser scientists. However, even your same university, always there are no interactions, no cooperation, or no synergy sometimes. However, this is a wave of the STI coordinator, show more wide waves. So when we apply this wide wave into these sharp peaks, then we can get one synthesized waves as a result of the interactions and the cooperation and synergies. These are the image of the role of STI coordination among the different scientists or different stakeholders. This is the spectrum image. I think some of you get already knowledge from the Professor Harris. And then with these minds, I and my colleagues of the STI coordinator at Kyoto University succeed to develop these ASEAN and Japan joint projects, namely JUSTIP, since 2015, supported by the Ministry of Education for the 10-year projects. That one is promoting the transdisciplinary research collaboration with three pillars: energy and environment, bioresources and biodiversity, and disaster preventions. And we set the joint laboratories as our core centers. Of course, in Indonesia, BRIN used to be the RIPPIs, our very important partner in the field of bioresources and biodiversities. And the energy and the environment is Thailand in NASTER, and the disaster prevention in Malaysia, Japan International Institute of Technology, MJIT. But these are the core, just not limited to these three institutions. This is a mechanism to promote the ASEAN and Japan multilateral collaborations, and then not only institutional level, but also using this JUSTIPnet. This is the mechanism to expand the networks of the individual researchers from the ASEAN and Japan. So this is one of the platform created by the STI coordinator at Kyoto University. And also, as I mentioned about STI coordination, we also try to increase the awareness or generate awareness of the STI coordinations, and also try to know the situation of the in ASEAN. So we conducted this survey since 2018 until now, collaborating with the ASEAN University Networks, ASEAN Foundation, or ASEAN Secretariat. And as you mentioned about INOMOS, this is an international network of research management society. We presented some of the results at this World Congress. And then what is the rationale of the STI coordination for ASEAN? ASEAN already launched the ASEAN Plan of the Action of the Science Technological Innovation since 2016 and 2025. There are 6 pillars, and just here several research development, but common trust or common parts are human resource development for the research development. So these are our activity contribute to the as a form of the human resource development for a research institution or university. And then this is one of the brief result of the surveys. So we conducted some surveys, and the objective is the self-evaluation, current status of research administration, and the required knowledge and skill as a science technological innovation coordinator in ASEAN region. We got 60 answers from the 50 institutions from 10 ASEAN member states, and the brief some results was about 70% of participants are under research position. There are not namely about a research manager or research administrator in ASEAN, but many such kind of the profession conducting such services as a position of the researcher. And then also, but there are many required skill, but capacity building opportunity to nurture the more young talents and the specialists are required, are not enough. So that's why, based on that kind of the survey, we continue some joint projects together with ASEAN Secretariat, as well as also University of Malaya. Namely Science, Technology, and Innovation STI Coordinator in Japan and ASEAN Towards Grand Challenge. We conduct twice time of the rounds online survey group meetings, in totally 11 times, and to generate awareness of research administration and the needs for professional STI coordinator in ASEAN. So one of the basics philosophies, minds of our study is like this figure, very easy. So tailor makings as our principle of co-creation. So left-hand side, you can see this very confusing rabbit. That suit shop just provide one size, very big size of the suits. So that's why the small rabbit cannot get a good fit of the suits. But the big rabbit also cannot get a good size of the suits. That one is one of the, not our targets. Our target is tailor makings. So by very, very carefully discussing sharing the information, we develop this kind of the tailor makings for the capacity development, or not capacity development, co-learnings amongst ASEAN and Japan. So this is the methodology of ASEAN and Japan joint project online co-learning mechanism. Start from the questionnaire developments and analysis of the results. And then based on the results, we conduct the online study group meetings. And then after the outcome or inside of the online study group, we try to textualize and making a diagram of the result of a discussion. And we repeat this one for 11 times. Then we integrate those kind of knowledge into the one summary report. This is open source. Anyone can utilize our result and the materials. So this is open. So please feel free to use for all any material. And these kind of material are available in this portal site. So you can utilize, this is our mission to share our common knowledge between ASEAN and Japan. And then we integrate the several knowledge among the ASEAN and Japan. In totally, about 700 persons total registered and participate our online series meetings from ASEAN and Japan. So then we share the common image of several well-balanced ecosystem of STI or system. For example, yes, now our society facing the several many interlinked, interprets the very complicated issues such as climate change, infectious diseases, or food securities, or even energy security, or biodiversity, or disaster prevention. However, under the uncertainty, but as one of the ultimate goal of the humanities, in order to solve this kind of grand challenge, we recognize the needs of the good research projects and STI policy and industrial innovation, as well as social contributions. In order to generate these kind of the points, we need to have the well-balanced STI ecosystem. How can we balance? We also identified 4 balancing factors. Namely, one is a top-down approach. The second one is the bottom-up approach, the curiosity-driven, or this is a policy-driven. And the other way, economic center approach, and also conscience-centered approach. Conscience means moralities, or human behaviors, or culture, or social aspect. So in order to make a balance, we need to have the good research management and administration, the coordination system. In order to coordinate, we need a good human resources, well-cultivated human resources, namely STI coordinators. So these are the one of the common image which share among the ASEAN and Japan. And second, what's the role of STI coordinators? This is also we share the role of STI coordinators. Simply, in order to solve very complicated issues or interrelated issues, we need to have the good collaboration within the academia, just not only within academia, but also academia and the governments, academia and the industry, even academia and the local communities. So what is the role of STI coordinator is bridging these sectors and coordinating these sectors among these sectors to generate or to initiate new initiatives as a form of the projects, as a form of the policy, as a form of the communication. During that period, there should be some process in the research management, namely pre-awards and post-awards to manage the project toward overall goal of the project. So we shared this image among our participants. So, and also we developed one of the concepts, namely STI landscape studies. This is how we could make a balance. This is one of the, 4 balancing elements, as I mentioned. And the important thing is this one. Here is a lot of the variety of the balance, like the health balance. Too much fat, too much sugar, it's not good for the health, but we need to have the very ideal balance in the food, nutrients, like that way. So one of the important things is STI coordinator need to diagnose the current status of the STI activity in your region or organization or country, or for example, but not only current stage. These persons need to think about the future targets, ideal condition, how we should achieve, what portion of the balance should be achieved in the certain period. By getting this kind of image, we can backcast and consider how to improve the current stage. So this is one of the way to make the good balance of the STI ecosystem for each region. So we are now trying to develop this methodology together with our colleagues, and also very welcome your advice and comment, just not only the researcher, but also students and for the next generation people. And here is also a very complicated, little bit busy figure, but through the one of the symposium, we also create one integrated knowledge of the ecosystem. And one of the, this is consists of the 3 layers of the ecosystem or STI between Japan and ASEAN. The bottom layers is a kind of the main activity of the STI coordination. This one looks like STI coordinators. And then green layer is a more visible layers that some of the platforms, network or research projects created or supported by the research administrator at STI coordinators. They will collect many researchers or scientists or engineer or policy maker to get a more good activity or interaction on the platform. Like today's symposium. But these platform reality supported by invisible, rather invisible, very sophisticated, dedicated person. That kind of the person are really important for activate this good platform. And then these platform sometimes generate some outputs as a form of entrepreneurship, STI policy, or research project, or anything else towards common goal of humanities. So these are the kind of the image. And then there should be some of the human capacity development. But one of the importance and what we could share between the ASEAN and Japan in terms of the ASEAN cultures, Asian cultures, one of the important thing is strong communication skill to build person-to-person trust and to publicize academic effort are very important. For that purpose, mutual trust and respect is the heart of the STI coordination. We share this kind of the very, normal knowledge, but this is a very important, essential factors, I think. So again, if we could, now we are trying to develop the STI landscape studies, and in case we apply this green technology, we may first consider what is the future ideal condition for your society, for your region, for your organization, and then backcast the current condition, how we can develop the necessary technology as a form of green technology, and then try to, go on the back to improve the research, not only the scientific activity, but also for the social science, humanity, and culture. Okay, so Russ, this is a summary to take home or for your reference. I hope I have still 1 or 2 minutes. So, okay, so science, technology, and innovation coordination, how to coordinate green technology and applied science for better futures. First, foresight and ambition, your ideal society and community to achieve in the future. Then discuss among each other to share common ideal societies and community for your country or region. Second, co-creating the common methodologies among, for example, now trying the ASEAN and Japan, but to evaluate the ideal condition and diagnose the current condition of the science, technology, and innovations ecosystem, namely STI landscape study. The last, to cultivate the namely STI coordinator from not only researchers, but also administrators, students, businessmen, and policymakers who have such kind of the, let's say, characters. Not the hard skill, but also the soft skill. To tailor-make STI solution for their society and the communities. And I think that you have these, yes, so good balance and a good balance and portion of the specialists in the society. Just not only one, let's say, one side, but also these kind of diversities portion are really important. So anyway, this is all myself. Thank you very much for your listening. Thank you very much.
Right, thank you, Sensei. That is very interesting presentation. I found a lot of inspiring quotes and message also. Thank you. And now we would like to invite participants. We still have a few minutes before we start the third keynote sessions. We have one from Mr. Ardi Manto. Could you can please open your microphone, and then Miss Anna Niska, And then we have one more. Sorry. From also Mr. Dieter Rahmadiawan. Also, we have. Should we limit the number of participants who question, Pak Chris, Pak Raymond? We have 4 questions. It's okay. Okay, we will continue with 4 questions. Right. For the first one, please, Mr. Ardi Manto. Silakan, Bapak.
Thanks, Miss Moderator. Please let me ask question. It is nice to meet you, Sonobu Sensei. Is related to your presentation regarding microwave technologies. So we applied microwave in mining industry to break the rock, and we found there is one crucial challenges that's related to the green technology. So we found that during the microwaving treatment, we still need more energy consumption. So I think this phenomenon should be solved in the future. And what do you think? What do your perspective on these things? Because we think if the energy consumption is still high, like this current situation, the industry will not use these technologies, especially in mining industry. So what do you think? Thank you, Sonobu Sensei.
Okay, thank you very much for your kind question. So I would like to little bit make sure what is the target material for the minings?
Rocks, yeah, rock, high strength of the rock.
High
strength. So it's basically, for example, andesite or quarry mining. Are you familiar with these types of material?
Yes, coal.
Especially granite, you know granite?
A granite, okay.
Yeah, for example, like that, yeah.
And then granite, you want to reduce or some extracts or synthesis? What kind of the
what we
process
want to do is reduce the stress of the rock by using microwave. This technology is application in mining is not a new technology. It's already in the past, but right now people are focusing on this.
Okay.
But the problem right now is not about the technology, it's about the energy consumption that's still high. So related to green technology, this is our challenges right now. How we deal with the situation.
Okay, I understand. So you're trying to reduce the strength of the rock by applying the kind of the technology.
In this afternoon section.
Okay, so I think the one of the way is that the microwaves, one of the very special character, that microwaves can be absorbed by the special material, not only a general. It depends on the its chemical and physical character. For example, waters or some kind of a thing can be well heated up until the 100 degrees Celsius. Probably rock have the water moistures. So that's why probably you are irradiating the microwave to the rock. However, if we put more microwave sensitive material, for example, carbon or the silicon carbides or some of the such kind of material can be more sensitive with the microwave. So I'm not sure how we can utilize, but using such kind of the microwave sensitive material, inject to the, for example, rock, and irradiate the microwave by transmission, then maybe something happen, I guess.
Thank you.
Thank you, Sensei, and we hope in the future we can collaborate together with University of Padang as well. Padang. Okay, thank you so much.
Thank you very much.
Thank you, Mr. Ardianto and Sonobu Sensei for answering the questions. We move on to the next participants. Miss Anna, you can start asking the question.
Okay. Thank you, Ms. Monica, for the time. First of all, I would like to introduce my name, Anna Niska. I recently joined UNP, and for myself, I really have great interest with the green technology because before I joined the UNP, I worked as assistant researcher and involving doing research in green materials, especially natural polymers. The material that I focusing was cellulose material. We extracted the cellulose itself from biomass or waste biomass or industrial waste, and and also as you mentioned in your presentation, you mentioned about titanium oxide, right? And as far as I know, that titanium oxide can be used as a catalyst, or it can also be used for purification, purification materials. And is there like, and my question is there any change that we can use this natural polymers, especially cellulose, we can combine it with the titanium oxide, so like we can probably make it more green, more green for the technology itself. Is there any possibility about that? And the second one the second one is about the obstacle that a researcher probably face during their research after they got a great result, and then they have like obstacle or difficulties in scaling up their research into the industrial scale. And according to your presentation as well, you said that we can make like a coordination with the industry or the government, but in our perspective as a researcher, is there like any advices that you can give to the researcher so we can like to make it our research, the result that we got, to be more useful to the society? Thank you.
Okay, thank you very much for your very good questions. You basically give me the two questions. One is how to well utilize cellulose material with titanium dioxide. So first, I would like to answer to that question. So I think there, yes, there are two. Maybe there are several ways, but I just come up the two examples. One is the cellulose can be extracted from the bio waste. And that cellulose can be formed to the more good film or biofilm or for example, fibers. And then other can be the membranes. And then we can embed it, the titanium dioxide on the surface. And that kind of membranes or sheets can act as a photocatalytic film to improve the, for example, curtain or your cloth. So that kind of the material can be utilized for the curtain on the house or surface of the coating of the buildings to clean up the waters to the hydrogen, or I don't know, or even the something the degradation of the some pollutant. This is the one way, and I'm not sure whether titanium dioxide can utilize for chemical reactions or dissolution of the cellulose itself, but some of the water extracted from the cellulose can be react with the titanium dioxide or something catalyst. So there should be some of the two way. And then another question about the coordination between the scale up of the research output to the industrial scale. I think there are also a huge challenge in Japan as well, even anywhere in the world, I think. But one of the things is those kind of the good coordination can be made by the good coordinators. And then good coordinator have the good, how do you say, human networks, the wider knowledge and a good skill to explain the very difficult scientific term to the other sectors. So I think our STI coordination try to cultivate that kind of human resources for better such collaboration occur.
Okay.
Is that okay?
Okay. Thank you, sir. Thank you for your kind question. Kind answer. That's all, I guess. Thank you.
Right.
Thank you very much.
Thank you, Miss Anna and Sonobe Sensei. Because of the time, we move on straight to the next participants to ask the questions. Mr. Dieter Rahmadiawan, please ask the questions. Okay, right.
Okay, thank you.
Yes.
Hello,
please.
Dr. Sonobe.
Hello, Dankeschön.
Yeah. So my name is Dieter. So actually, I just curious about the so green technologies also interest me. I also do the research about green technology when I was in master. So my thesis title is actually working on the lubricant derived from polyester oil, and we use cellulose as the additive. So we prepare the cellulose into powder and mix them to the lubricant. And it is really interesting because it improves the tribology properties. And however, I also investigate the life cycle, the assessment of the life cycle of the product. And from what I've learned, it looks like let's say in the future, if we use all energy, if we use all of the material is from green energy, maybe 90% using energy in the 20 or 50 years from now, then it means that we also increase the needs of resources. Let's say that we're talking about cellulose, which is from trees, right? So if we using all of the things is from green materials, so means that the consumptions of the cellulose will increase, then we need to plant more trees, and then we meanings that more trees will be cut and more land will be needed. So what do you think of this, Doctor? How do you balance my perspective? Thank you.
Okay, thank you very much. It's a really good question and a hot topics. And I think what of the important thing is here's we need to consider about the four balance. One is yes, top down and bottom up is related to research itself, project itself. But for the society, we need to consider economic center approach and conscience center approach. So it means economic center approach, as you may say, we need a resource, we need energy for our benefits, for our revenues. So we try to be the very high competitive to get the resource from the other. No way for the other. It's a little, and then try to get the natural resource. This is a very, very, how do you say, like the extreme condition. However, probably in the realities, we need to make a balance, good biodiversity, the good environmental factor, or good relationship among the families or among the neighbor countries. In that case, there should be some of the other force to make the balance in terms of the conscience-driven STI. So this is one of the concepts, and also more detail. We need to, let's say, utilize the bioresources. We need to also consider about the conservation of biomass, bioresources. And we need to have the more efficiency, or we need efficient technologies, on efficient technology, efficiency use of the technology or energy or consumption. And also need to change the lifestyle as well to adapt to the such kind of future such situation. So this is consider what is the ideal condition in the future. So scientists need make this one clearly for your society. So I think there are several things, but probably we can discuss later. Thank you very much.
Thank you, Doctor.
Thank you, Mr. Dieter. Maybe you can continue the discussion further with Sonobe Sensei, right? And then we move on to the next participant to ask questions, Mr. Aprizal Saputra. You can open your microphone and start asking the question.
Okay, thank you, Miss Monica.
Right, thank you, Pak.
Before I answer the question, I introduce myself. My name is Abdul Saputra. I'm a student in Department Mechanical Engineering, Universitas Negeri Padang. So I have two questions about your context and out of your context. The first question about how to the Japan government release the NIDO. Do university in the Japan get involved with this project? Mr. Shanobe Sensei?
Okay, you're asking about NEDO?
Yes.
Yes. NEDO is one of the funding agency under the Ministry of the Economy and Trade and Industry. They provide the fundings to the basically industry in Japan and university implementing to the also Indonesia about clean energy or something. I think there you can Google carbon neutrality or Asia green growth strategy. You can get some of the more further detailed information from here.
Yes.
I'm not sure I can answer to your question properly.
Aprizal, apakah jawaban dari Sonobe Sensei tadi sudah menjawab pertanyaannya, Pak?
Sudah. And next, the question about scholarship. Now I'm a student at Universitas Negeri Padang. I will plan to study in Japan. Can I apply the program in Kyoto University? And what kind of scholarship and requirement to apply master degree in Kyoto University?
Okay, thank you very much. So I think there are several two options. And a very important thing is that, yes, now coincidentally, we have the good partner with the University Malaya. There is our joint degree program between the University Malaya and Kyoto University for the master. So that one is also one of the joint, let's say, you can get the supervisor from University Malaya and Kyoto universities and study at both universities as a students under the Malaya and the Kyoto University. And more direct study to the Kyoto University. I think there is an embassy scholarship every year from the Embassy of Japan in Indonesia. Normally that open from the April or May every year for master and PhD. So I think that you can try to get the information from the Embassy of Japan, and then you can apply. And then same time, you need some of the host researchers to be the supervisor in the future.
Right. Baik, Bapak Aprizal, does that answer the questions? Sudah terjawabkah, Pak? Oh, masih mute, Bapak, maaf.
Sudah, Bu.
Alright. Thank you.
Sensei Sanobe.
Right. Thank you, Sonobe Sensei. Thank you, all the participants who have given questions in this sessions. Just like before, as a token of appreciation to Dr. Taro Sonobe, the committee has prepared, and we would like to present a certificate for your amazing contribution to the symposium. It will appear on the screen in a moment. There you are. So Sonobe Sensei, please accept this certificate in recognition and appreciation of your contribution as a keynote speaker in the 4th Progress in Science and Technology Research Symposium 2022.
Okay, terima kasih. I'm also sincerely appreciate to your kind give us a very great opportunity and wonderful session today. Thank you very much.
You're very welcome. Right.
Arigatou gozaimasu. I hope next time you can visit our campus.
Yeah.
Yes, it's true. We look forward to having you here in Universitas Negeri Padang for a visit, Sonobe Sensei.
Yes, terima kasih.
Right. Okay, ladies and gentlemen, we will move on. Miss Okta Suryani, PhD, are you here?
Yes, I'm here.
Right. So, ladies and gentlemen, we will start the third keynote session with Okta Suryani, PhD, who has been with us since the morning. Hello, Miss Okta, are you okay now? Right.
Yeah.
Okay, we look forward to listen to your presentation. But before that, allow me to introduce the short biography of our own Okta Suryani, PhD. She was born in Solok, West Sumatra, Indonesia, in 1989, so she is still very young. She received her bachelor degree from Universitas Negeri Padang in 2012 and continued to pursue master degree in science in 2015 from Universitas Gadjah Mada. And then she obtained her PhD from Tokyo Metropolitan University in 2018 under the supervision of Professor Yuji Kubo. And then in the same year, in 2018, she was appointed as a lecturer at the Universitas Negeri Padang in chemistry department. Her interest is in organic synthesis, supramolecular analytical chemistry, self-assembled materials, and semiconductor for hydrogen production through water splitting. Her works have been published in reputable journals. So if you are interested in her works, you can search in Google Scholar or in her Scopus. Right, Miss Okta, are you ready now?
Yeah, I'm ready.
Okay, so ladies and gentlemen, please welcome Miss Okta Suryani, PhD.
Thank you, Miss Monique, for the nice introduction. And let me to share my slide. Did you see my slide?
Yes, it's already on screen. Maybe you can put it into slideshow. All right.
Okay, thank you very much, Miss Monique. And I'm very delighted to talk in this symposium actually because this is the first time for me to be a keynote speaker actually, but it will be very, very, very interesting. So I hope you can enjoy what I will talk in this occasion. But please wait because my laptop is now cannot working, so please wait. Okay. Today I will talk about the near infrared absorbing organic photosynthesizer for dye-sensitized hydrogen production, which is this is my research that start from 2015 until now, which is it has done about 7 years, and the data and the result that will be presented in this presentation are done by collaboration work between Department of Chemistry Universitas Negeri Padang and also Department of Applied Chemistry of Tokyo Metropolitan University, while here we are working with Professor Yuji Kubo. He is my supervisor during my PhD, and Yuta Higashino, he is the co-worker in the laboratory, and also Dr. Mawadi and also Dr. Trisna Kumalasari from Department of Chemistry. Actually, my research is related to the presentation that Sonobe Sensei talked before, and we are talking about green chemistry, we are talking about the hydrogen production and renewable energy. So I hope you can enjoy this theme again for 60 minutes in the future. So let me to start this presentation. And we know that now we are currently facing two minds of challenges, which is first, energy crisis because of depletion of hydrocarbon fuel resources. And the second problem is the impact of the use fossil fuel itself to the global climate change. And in this regard, this is the effect of the emission of greenhouse gases. So to reduce our dependence on fossil fuels, we need to make a large-scale transition toward new by finding sustainable and clean sources of energy. Among renewable energy resources, uh, so we are thinking about the solar energy. Solar energy is the only source that has the potential to meet all of our energy needs. Why? Because we can harvest more than 20 terawatt of energy from the sun, while it only uses 0.16% of the Earth's surface to be covered with 10% efficient of solar cells. And so this 20 terawatt is enough to fulfill our need for energy consumption. Furthermore, if we are talking about harvesting of solar energy, there are a lot of ways to harvest the energy. But in this case, we are choosing the storing solar energy in the form of chemical fuel. Why chemical fuel? Because we know that chemical fuel is easy in transportation and also normally have high density energy. So in this case, we also know that there are a lot of chemical fuels, which is methane or biomass. But in this case, we choose hydrogen. Why hydrogen? Because hydrogen, in combustion reaction, it gives off only water and energy. There is no another gas product, and also has the highest energy density among other chemical fuels. And if we talk about harvesting solar energy, the best way to harvest solar energy is convert into hydrogen is using water. So why water? Because water is a convenient and abundant source of hydrogen. Indeed, it's inspired by nature through photosynthesis. Photocatalytic water splitting, where the split of water to be hydrogen and oxygen, promising the best way for procurement of hydrogen fuel. It is because there is no greenhouse gas as a gas byproduct generated in the process. However, we can see over here the reaction to split water to be hydrogen and oxygen need energy, which is 237 kilojoule per mole. So this reaction is not easy. Easy to talk, but not easy to be done. So a lot of research has been published to split water to be hydrogen and oxygen. The first time is Honda and Fujishima in 1972. He is working on a cell, it called photoelectrochemical cell, where they are using photoanode, which is titania, and also cathode, which is platinum. And the other type of system to split water is BART in 1980. In this system, they use not photoelectrochemical cell, but only use photocatalyst using platina-loaded titanium oxide powder. So there is no electricity in this system. So actually, I'm working in this two kind on both of the system. So I will talk about two of the system. However, if we see over here, the focus in this system is titania. This is also titania. So we know that titania is the semiconductor. So we will focus on this kind of aspect. So now I will show you the titania that everyone knows maybe that titania has a band gap around 3 until 3.2 electron volt, and which is this titania absorb a wavelength about 387 until 430 nanometer, while this is a UV light absorption. However, if we are talking about the harvesting solar energy, we know that sunlight spectrum is not only in 300 until 400. We know that sunlight spectrum is ranks from 300 until 2000, actually 2000 nanometers. So if we say that we are not harvesting solar energy at all, only about 20% maybe. So 80% are wasted. So we are trying and struggling to harvest this kind of wavelength in sunlight energy. So how to improve the absorption of this titania? So we need dye sensitization. What is dye sensitization? Sensitization, sorry. This is while the titania combined with a dye, and we hope it will improve the light absorption of the sun. So photosensitizer is necessary to be used to extend the absorbed portion of solar spectrum to improve the efficiency of the system. Okay, a lot of photosensitizer has been synthesis actually. As we see over here, mainly the photosensitizer using metal, which is ruthenium, and here is a platinum. We know that ruthenium and platinum is a metal that not green chemistry. I mean, it has a lot of side effects. So we are thinking about using metal-free organic photosensitizer. Because it has large structural variety and tunability of optical properties. And here reported metal-free organic photosensitizer used in dye-sensitized hydrogen production already. One is synthesis by Sun, and it is published in Journal American Chemical Society. It only absorbs invisible light in solar spectrum, which is 480 nanometer, and the second one is absorbed at 510 nanometer. So we can say that organic photosensitizer that been synthesized is only covered from UV to visible, which is this 400 and 500 is visible area. So let's take a look again in sunlight spectrum. So we are, the scientists still harvest UV and visible, but there is near infrared and infrared area over here. So about 50% of sunlight spectrum. So near infrared and infrared light to be considered 50% of total sunlight is unused in the system. So we think that photosensitizer harvesting near infrared light are worth to be preferred. In this laboratory in Tokyo Metropolitan University, we have already synthesis kind of this boron dibenzoperomethyl dye, and this is already published that this kind of dye has absorption in near infrared. So we are really try to apply this kind of dye to photoelectrochemical cell or in photocatalyst sensitizer. So the topic in this system will be divided into two kind of system. First is near infrared absorbing boron dibenzoperomethyl for application in dye-sensitized photoelectrochemical water splitting, and the second one is feasible to near-infrared light-driven photocatalytic hydrogen generation using boron dibenzoferromethane. So the difference is the system. I will start with the first topic. Here you can see the system of dye-sensitized photoelectrochemical cell, while we need titanium as a semiconductor, and also we need photosensitizer, and then we need water oxidation catalyst over here, and also we need platinum as a cathode, and in the anode we use FTO glass. So we start with the designing of a new metal-free organic photosensitizer. Over here, we design a new kind of dye, while how we synthesize this dye, because of in our lab, this body P, I mean the benzoferromethane, has shown that their lambda maximum is about 640 nanometer, so it will be near infrared region, and we need the other of kind of group to anchor this dye to titanium semiconductor. And also we're trying to make a calculation of the properties of this dye before synthesis this dye. Okay, this is the synthesis of the dye. There are 1, 2, 3, 4, 5, 6, 7, 8 steps of synthesis, while all of the compound have been characterized using proton NMR and carbon NMR, also boron NMR, fluorine NMR, and also elemental analysis. This target compound also identified by several spectroscopic analysis. And this is the spectroscopic analysis, which is absorption spectrum of D1, the dye. The absorption spectrum of D1 was observed in THF solution, which shows lambda maximum at 687 nanometer, with the molar extension coefficient of 1.09 times 10 to the 5th molar per centimeter. However, we can see the onset value is start from 728 nanometer, meaning that this dye can absorb near infrared light. The spectral feature have also been characterized by TDDFT calculation. From the result of TDDFT calculation, the maximum absorption band is mainly ascribed to the HOMO and LUMO transition, while the surface plot shows that the electron density from HOMO to LUMO, while the electron before irradiation should be in this benzodiferromethane side, and after irradiation or after excitation, the electron will be moved into this part of molecule. So we can conclude that the surface plot showed that electron density from body P to rhodamine moiety. And the next characterization is electrochemical properties, which is the cyclic voltammetry of dye in solution shows the E half at 1.074, and the obtained data from this experiment used to calculate HOMO and LUMO energy level of D1. So where LUMO we calculated, it should be LUMO is at minus 0.721, which is higher than conduction band of titanium. And the results shows that if this dye absorb energy, so after excitation, this excited electron can be injected to titania. So we conclude that this dye met the precondition to act as a sensitizer for dye-sensitized photoelectrochemical cell. And the next is the preparation of photoanodes. Here, in order to investigate the capability of dye as a photosensitizer for dye-sensitized photoelectrochemical cell, two kinds of photoanodes shown here were prepared in line with this protocol. The calculated loading amount of D1 was 3.07 times 10 to minus 7, and C1 loading amount was 0.909 times 10 to minus 7. And then we are investigating the absorption spectra of D1 in THF acetone and C1 in methanol measured by a solid line, and after its dotted line, the film deposition. So the dye was deposited in the film, and it will be used for the system. The decrease in the absorption indicates the absorption of the substance onto titanium. Here, this is the film, and the absorption, we can see that it will absorb from 400 to 800 nanometer. So it will not absorb UV and visible, but it can absorb near infrared wavelength. And then this is the setup of the experiment. We are using FTO and titanium dye or working electrode, and then reference electrode here. Counter electrode is platina, and then we using xenon lamp as a source of energy instead of sunlight. Based on this experiment, the onset potential of oxidation in the film was evaluated by cyclic voltammetry. The green line shows that CV of D1 only electrode. The blue line shows the CV of only catalyst, which is C1, and the red line is the CV of D1 and C1. And also we found a new peak that assigned as ruthenium. Here we use catalyst, while ruthenium as the main core of the catalyst. In this system, we can see that there is a peak of ruthenium and ruthenium-4 oxidation. Therefore, the co-absorption of D1 and C1 was confirmed. And this is the comparison between the photocurrent density of D1 and photoanodes. So this is the current that harvests after irradiation. So if we use catalyst, in the green line is with only photosensitizer, but the red line using photosensitizer and catalyst. So we can see that there is effective electron relay because of the photocurrent is higher than without catalyst. And also we are checking the IPCE spectrum. While in this case, the absorption properties of D1 in we are checking the absorption properties of D1 in film, and IPCE spectrum also shows photon conversion to current up to 800 nanometer from visible to near infrared region. So we are trying to make the energy diagram on this system. First is the result of photoelectrochemical experiment that shows photo-induced water splitting process. While the higher value of oxidation potential of D1 that observe water oxidation onset will facilitate the electron transfer from the catalyst to photooxidize. So when a photosensitizer absorbs light, it will excite it into LUMO, and then this dye, this photosensitizer, inject its electron to titania, and then this titania, the electron will go to the system in electrochemical cell. After that, this electron will reduce proton in the world to be hydrogen, and at the same time, the water, this proton should be resulted from the catalyst water splitting, while this water split by water oxidation catalyst and produce oxygen and proton over here. This proton is reduced by the electron that injected by the photosensitizer. So the result of longer period of photolysis with 2000 seconds irradiation are shown in this slide. Hydrogen and oxygen evolution was confirmed in the cathode compartment by GC. So we can see the peak of hydrogen in the gas chromatography, and the highest Faraday efficiency of hydrogen is 65.8, was produced by the 1C1 system and at the pH 7.2. This value is higher than the one only system, and it was so much higher, which is 4.5 times higher than the system using photoanode assemble of 3-phenylamine dye that absorb visible light radiance. So it means if we use near infrared, the energy harvesting is 5 times higher than using photosensitizer that only absorb UV and visible photosensitizer. So the conclusion in this system, so this is actually, we are very proud to say that this is the newly synthesized high absorbing rhodamine containing dibenzo body P. So there is no near infrared photosensitizer before that already synthesized to use in a water splitting system. We are very proud to say that this is our effort can be done in this research. And the dye-sensitized photoelectrochemical system assembled from this photosensitizer shows photo driver water splitting to produce hydrogen and oxygen, while the efficiency is 65.8 and for oxygen is 76.4%. Next, we are continuing to the second system, while we are not using photoelectrochemical anymore, but only use the photocatalyst. So I need to make a brief introduction about dye-sensitized photocatalyst. Over here, we are still using photosensitizer, which is organic photosensitizer, and using titanium as a semiconductor. And in this system, we are not using catalyst anymore, but only use sacrificial agent such as vitamin C or ascorbic acid. So again, why we use photosensitizer? We need the photosensitizer that has excellent electron injection, high photostability, high absorbing properties, and harvest wide light spectrum. So again, we use body P as a dye photosensitizer. And in this kind of in this research, we are not only focused on near infrared, but we are trying to synthesize panchromatic metal-free organic photosensitizer. What is panchromatic metal-free organic photosensitizer? This is the dye which is absorbed from UV, visible, and also near infrared. So all of the spectrum can be covered by this photosensitizer. So we hope by these properties, the solar energy can be harvested more and more, and the efficiency will be increased as well. And in this research, we are using we are using dibenzoyl that we call body P, And we also use this kind of moiety, which is phenothiazine. And in this research, we are trying to prepare the dye first, and also prepare the system, and then investigation of hydrogen production performance of the resultant dye sensitized photosensitizer. This is the synthesis step. I will keep it. Okay, and then this is the optical properties of the dye. Actually, in solution, this dye has the absorption, the highest absorption at 638 nanometer, and it's look like visible absorption. Yeah. However, I will show what happened next. So, and now we are trying to explain why this dye has absorption at 638 nanometer, because of the electron transition from HOMO to LUMO +1, and we can see over here electron density was in body P moiety, and after excitation it's become to the phenothiazine part. In this case, before we are preparing the system, we are also preparing the semiconductor, which is titania. This is the titania that we have already synthesized. This kind of titania called hierarchical porous titania, because of this titania contain porous that not all of the porous have the same diameter, but hierarchical, because there are the big one, the small one, and they are combined together. And we found that because of this kind of porous, this titania has a higher photocatalytic activity. And this is the XRD analysis, said that the crystal phase is anatase, and based on BET measurement, the absorption is said that surface area is 44 meter per gram. So the active area is 44 meter square per gram. And this is the preparation of photocatalyst. So, and this is the also characterization. And now I will show you that before the deposition of dye, this is the green one is the absorption of dye in solution, which is this is invisible area. But after we deposited the dye to the titania that we already synthesized, the absorption become higher. I mean, it start increase, and also higher. I mean, it start from 400 until 707. Sorry, 717 nanometers. So it is said that this is a panchromatic dye. So because it's showing a panchromatic property, and also red shifted absorption band compared to the in solution in the HF. And also after that, we are focusing on hydrogen production experiment. The gas chromatography confirmed that evolution of hydrogen gas at 4 hour and 20 minutes retention time. 4.20 minutes retention time. And over here we can see that hydrogen gas was observed even after 2 hours. After 2 hour irradiation, it still produces hydrogen, while the turnover number still increase. It means this kind of dye is stable in the system. There is no the depletion of the producing of hydrogen. And after that, we are checking the stability of this photocatalyst. In this kind of experiment, we are trying to doing irradiation of the photocatalyst until 10 hours. After that, we stop the irradiation and then keep it in the dark for 10 hours. After that, we use it again, and in this kind of data, we see that after 10 hours of irradiation, the turnover number is almost same, and it seems increased. So it means the stability of this dye is very high in the case of use in dye sensitized photocatalyst. So this is also proved by the electrochemical experiment. While we can see over here when if we use irradiation, so there is a photocurrent density, and if we stop the irradiation, it will be there is no photocurrent, and if we start again, there is a photocurrent. So there are 4 cycles that has to be done, and it shows the stability. And this is the energy diagram, and over here the HOMO of the synthesis dye is 0.98 volt, and the LUMO is minus 0.85, and this is quite short. So because of that, this dye is has a property to absorb in near infrared region. And after irradiation, this dye will inject the electron to the conduction band of titania, and then this electron will be used to reduce hydrogen in the water to be to reduce the proton, I mean H plus, to be hydrogen in water. Yeah, to keep the system stable, we use ascorbic acid, which is vitamin C, to make the dye also keep not undergo the photo degradation. The external quantum efficiency also the important finding of this study, because the measurement of the external quantum efficiency, or EQE, conducted under single wavelength irradiation, calculated using the formula over here, and this table shows that photocatalyst is still active in producing hydrogen even when irradiated at 670 only, 700 only, and 750 nanometer. So the generated EQE data correspond well to the dye absorption. This study demonstrates for the first time a panchromatic hydrogen generation by a metal-free organic dye has been successfully applied in hydrogen production. If we try to compare among metal-free organic photosensitizer, here we can, this is the dye that already recorded, and this is our system. So in our system shows the highest TON number, and also the highest TOF number, and the activity also the highest one. So we are very glad to see this data. And then so in conclusion, the photocatalytic hydrogen production from water in the DSP system sensitized by metal-free photosensitizer body P, this one, proved to be the panchromatic hydrogen generation by EQE value, and showing better hydrogen production compared with visible absorbing dye. And the AQE value were consistent with the absorption of this dye in solution and also in thin film. And then in comparison with reported metal-free organic dye, this dye showed better hydrogen production performance with TON and TOF number of 10-hour irradiation due to wide absorption spectra up to 800 nanometer, which is panchromatic dye. I think so. Another conclusion is so we need to conclude that near infrared absorbing boron dibenzopyrromethane can contribute for development of metal-free organic photosensitizer in dye-sensitized hydrogen production system and in both a photoelectrochemical and photocatalytic way. And so I need to say my gratitude to the team of research in Department of Applied Chemistry, Tokyo Metropolitan University, and also the research team in Department of Chemistry, Universitas Negeri Padang, and also to the LP 2M, Lembaga Penelitian dan Pengabdian Masyarakat Universitas Negeri Padang, for providing grant for a part of this study. So thank you very much.
Right, thank you, Ms. Okta Suryani, for the presentation. Now we still have a few minutes before we go to the lunch break. We invite participants to ask the questions. You can use the raise hand feature, or you can type your questions in the chat room. Okay, maybe most of our participants are getting ready for the lunch break. So, Ms. Okta Suryani, I have one question for you. Yeah,
Okay.
it's about time for having lunch, right? So, I have one question for you. Since my background is science education, so I am preparing the professional background for a science teacher, future science teacher. So if you could have one message to the future science teacher, what would that be based on your research?
I think because of in line with Taro Sonobe Sensei presentation, all of the research now is focusing on green chemistry. So I think all of the teacher and science teacher in the future should try to study about the green chemistry and also about the clean renewable energy, because of this is the important thing to keep our life in on the best
Sustainability,
track,
right?
Yeah,
Sustainability of our life on this
Yes.
planet, right? So one of the problems in science education program is that most of pre-surface science teachers feel they are living in the different world, that they feel they are apart from the green technology or sustainable development, but in fact they are not. They are part of it. So thank you for your message, and I'll try to convey your message to the pre-surface science teacher of Universitas Negeri Padang or on a larger scale. Right, ladies and gentlemen, because it is now already past 12 p.m., it's time for us to have a long break. We would have 90 minutes for lunch break. And then we will come back again in this meeting room at 1:30 p.m. We will continue the conference with other 4 keynote speakers in the afternoon session, and we hope that you will stay tuned for the afternoon sessions. And then before we close the session, we would like to present the certificates as a token of appreciation to Ms. Okta Suryani, PhD. It will appear on the screen in a moment. Right. So please kindly accept this certificate, Ms. Okta Suryani, in recognition and appreciation of your contribution as keynote speaker in the 4th Progress in Science and Technology Research Symposium 2022.
Thank you, Ms. Mone. I'm delighted to receive this certificate, and thank you for the committee and also Universitas Negeri Padang.
Right. You are certainly most welcome. Right. And then that's I think that marks the end of this first plenary sessions. As your moderator, I would like to excuse myself, and please, I do apologize if there is any misconduct in my moderations. I would really look forward to see you, all researchers, students, and keynote speakers in the future opportunities. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Bapak Ibu yang berbahagia, kita istirahat siang dulu sebentar sampai jam 1:15. Kita masuk kembali 1:15. Nanti jam 13:30 kita langsung parallel session. Nanti Bapak Ibu tolong dirubah rename akun Zoom-nya. Nanti biar panitia dengan mudah untuk masukkan Bapak Ibu ke dalam parallel session. Sampai jumpa nanti jam 13:15.
Universitas Negeri Padang merupakan salah satu universitas unggul di Indonesia yang selalu berkomitmen memberikan pelayanan terbaik kepada masyarakat. Laboratorium Terpadu Universitas Negeri Padang telah terakreditasi ISO IEC 17025-2017 melalui Komite Akreditasi Nasional dengan nomor LP 1641 IDN yang diterbitkan oleh Komite Akreditasi Nasional pada tanggal 25 Mei 2022. Laboratorium Terpadu UNP berhasil meloloskan 11 jenis pengujian dengan metode uji internasional dan nasional seperti American Standard Testing and Material, British Standard, dan Standar Nasional Indonesia. Jenis pengujian yang diakreditasi meliputi pengujian batu bara, pengujian kuat tekan beton, pengujian tarik, pengujian kekerasan bahan, dan pengujian X-ray diffraction.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Alhamdulillahirabbil alamin. Kita panjatkan puji syukur kehadirat Allah Yang Maha Kuasa. Hari ini Laboratorium Terpadu Universitas Negeri Padang telah terakreditasi ISO 17025 terkait dengan bidang pengujian logam maupun kimia, fisika, dan lain-lain. Oleh sebab itu, kami menghimbau kepada para pengusaha, dunia usaha, dunia industri, maupun para peneliti, institusi pendidikan tinggi yang memerlukan pengujian bahan terkait dengan pengujian mekanik maupun kandungan kimia fisika dari struktur bahan yang dibutuhkan dalam pengembangan dunia usaha maupun dunia industri saat ini sudah tersedia di Universitas Negeri Padang. Ini adalah satu-satunya laboratorium di Sumatera bagian tengah yang terakreditasi 17025 Dan tentu ini sangat membantu kepada dunia usaha maupun dunia industri, para peneliti untuk memudahkan proses pelaksanaan pengujian-pengujian terkait dengan bidang mekanik, fisika maupun kimia. Mudah-mudahan ini bermanfaat untuk kita semua. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Pengujian kualitas batu bara di Laboratorium Terpadu UNP menggunakan peralatan yang canggih dan terbaru, serta menggunakan standar pengujian ASTM, sehingga hasil yang dikeluarkan dapat dipercaya dan dipertanggungjawabkan. Parameter uji yang dapat diukur diantaranya pengujian kalori, uji sulfur, kadar abu, zat terbang, dan kadar air. Pengujian kuat tekan beton saat ini menjadi primadona karena semakin gencarnya pembangunan yang ada di Indonesia. Labor Terpadu UNP menggunakan pengujian SNI 1974 tahun 2011. Pengujian kekuatan tarik di Labor Terpadu UNP sudah memiliki market yang sangat luas karena pertama di Sumatera Barat yang telah terakreditasi Komite Akreditasi Nasional. Metode pengujian yang digunakan yaitu SNI 2052 2017. Pengujian X-ray diffraction berfungsi untuk mengetahui profil kualitatif difraktogram 2 theta dan intensitas sinar X. Metode uji yang digunakan British Standard, European Standard 13951.
Department now already have an ONKA certificate. So we hope in the future we are better and better in every single process in this department. So we invite you to
itu pakai
Halo, Assalamualaikum Bu Ii. Kita di Bapak Ibu bagi yang sudah silakan bergabung ke dalam room masing-masing.
Ya, kita mulai Pak Remon. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good afternoon, committee, guest, presenter, and participant. May I have your attention, please? Yeah, let me inform you about to begin. Thank you very much for preparing yourself to rejoin our virtual symposium. Bapak Ibu, terima kasih atas waktunya kembali bergabung. Dalam waktu dekat ini, kita akan memasuki sesi seminar paralel. First of all, I'd like to make ready of your device to join in room. Our committee will organize you into room. Please don't forget to make a new rename. Jadi silakan Bapak Ibu merename kembali nama virtualnya dengan aturan kode R, kemudian diikuti dengan nomor, lalu nama. Ya, sehingga panitia mudah memasukkan Bapak Ibu ke dalam room yang akan mempersilakan Bapak Ibu presentasi. Well, for your information, our session will be start sooner. We will stay in this position from 13:30 to 15. You can check your book of abstract for more complete guidance of this event. Jadi tentang ruangan telah disampaikan di buku abstrak. Nah, Bapak Ibu, I'm here to guide you as moderator from this session till the end of event. I'm Muhyatul Fadilah. Please call me Miss Ii. And now time is yours to join at your room. Committee, please.
Q&A, question and answer. So I will call you to the presentation based on the list of the parallel session in room 2. And so I hope you engage this conference and hopefully we will get the benefit regarding this session. And for the first change, with the presenters, first, Mr. Eki Anthony. Mr. Maximum 10 minutes.
Okay, most of participants have been already joined to the room, especially for the presenter. Untuk peserta, silakan memilih join pada room yang diinginkan. Jadi mungkin sesuai dengan bidang, maybe your expertise or you are interested to the particular topics. We are pleased you to join at your specific room. Thank you very much. Suci. Some presenter are still in the main room. Suci. Kami ulangi, Bapak Ibu yang presenter boleh segera bergabung kepada salah satu room yang diinginkan atau dituju. Good afternoon, participants. For you who are still in the main room, you are pleased to join in one of room that you intend to. Silakan Bapak Ibu boleh bergabung ke salah satu room yang disediakan. Terima kasih.
Okta, silakan kembali ke.
Assalamualaikum Bu Okta. Bu Okta. Bu Okta.
Waalaikumsalam.
Ya,
Ya,
Bu Okta, bisa masuk gabung ke grup satu lagi, room 1, Bu.
Oh iya Pak.
Ya.
Jangan lupa di apa?
Jangan lupa di record ya, Bu.
Oh iya siap Pak. Makasih banyak Pak.
Silakan klik join-nya ya, Bu ya.
Ya.
Ya, terima kasih Bu. Assalamualaikum.
Waalaikumsalam. Makasih Pak.
Bu Okta, kalau yang room 3 gimana caranya masuknya?
Oke Pak, Bapak room 3 kita pindah ke room 3 ya Pak.
Oke.
Pak Hendri.
Hendri Masdi.
Silakan klik join-nya Pak Hendri.
Pak, kalau pindah ke room 3 boleh, Pak?
Dengan Pak Aswardi, Pak.
Ya.
Room 3, baik Pak. Ya, bagi yang untuk mau pindah room silakan rename namanya R1 atau R2, maksudnya room 1 atau room 2. Silakan rename namanya biar kita bantu untuk pindah ke room.
Mohon maaf Pak, untuk room 1 Pak.
Oke, baik Bu.
Ada delay ya?
Nggak join. Oke Bu Anissa, silakan klik join-nya Bu.
Assalamualaikum Pak atau Ibu, masukkan saya ke room 3.
Sebentar Ibu Elita ya, room 3 Bu.
Yes, thank you.
Sama-sama Ibu.
But if there is no question, we can next to the second presenters. Okay, we next to the second presenters is Mr.
Pak Dori.
Henry Nur.
Ada yang minta masuk ke room 3?
Mr. Henry Nur.
Ya, minta bantuan room 3.
3 Ibu.
Ya, Bu Elita Zusti. Bapak Ibu yang belum masuk room, tolong dibantu untuk merename ya Bu dengan menempatkan nomor kode room di depan nama.
Terima kasih Bu.
Ya Bu, sama-sama. Elita, ya. Elita Zusti Jaman. Ibu Ahyuni mau ke room 4 ya Bu?
Ya Bu.
Sebentar ya Bu, room 4. Ibu Sri Mutia ingin dimasukkan ke room 3, Bu. Mohon bantuan Bapak Dori. Ibu Sri Mutia. Sri Mutia.
Right. Okay, are you ready? Still hearing? Okay. Ready? Action. And on the phone, we had 10 minutes, okay? Minute for presenting and key initiation of the